I don't even pick up my phone. I don't pick up my phone. I don't know who you are, so I want you to leave me alone. Leave me alone. Leave me alone, yeah. Leave me alone, yeah. I don't know you. Who the fuck are you? Get away from me. I don't know you. Why you looking at me? I don't got no. These views ain't free. I don't want you talking to me. Why don't you go away? Stay away. Fly away. Far away. I will pay to fly you away as long as you go. Get away, ho. I don't know you like that. I don't want you like that. I don't even know your name, and you got a big gap in your teeth. So get away from me. Get away from me. Get away from me. What do y'all think? That's my new single. It's coming out June 18th. Okay, like, comment, subscribe if you're feeling my music. Okay, this programming thing just a side gig, brother. I really be making music. It's my passion, and you can see it in my talent. Okay, brother. Now, let's change focus. Let's just. I had some for a second. Don't lie. I had y'all going for a second. I just wanna be alone. Get off the phone. Let me go home. I don't wanna get no dome. I don't wanna. We'll work on it. We'll work on it. Okay, so welcome back to the SwiftUI Learnalong. I am your host, he who exists. And yesterday, to get you caught up, brother, we were fucking around with these protocols, which are very cool. They're, I suppose you could consider them, the more and more I think about it. I think about this often, but the more I think about it, I'm like, these are really almost, it's like not a type check, but like a shape check. So in addition to a type check, even though it is a type in and of itself, so I guess it's kind of the same thing. But what's interesting about it though is that it's not, well, actually, I don't know. See, I'm going back and forth because let's just take a look at it from a beginner's perspective, right? Based on the other things that we've seen. Let's just meander on this a bit. So protocol, syntactically, looks very similar to, you could turn this to, turn that into a struct and okay, well, that's the difference, right? It looks the same, except in a struct, you would actually write out the body and the logic and stuff like that for your different properties, which you can't do in protocols. So you're not actually, computing or even defining how something might get computed in a protocol. You're simply saying what a given thing that you want to conform to it must have. So maybe not, maybe shape is not the right thing, although it kind of is. But I like the fact that it, actually, no, now that I'm staring at it, I think a better way to think about this, because, we have types right here, right? This is obviously a type. So this is saying that the variable number of rows is of type integer. Simple enough, yeah? And if you expand on that, you can even say, like we looked at classes a couple episodes ago. And so we know that you can assign similar to, like here's one now. So just like this syntax here, if this was class and department was a class, tabular data source could be a superclass, right? So the annotations look very, very similar. But what's different is that you're not adhering to just the singular type itself. So like ultimately even if a struct, well, like in this case, a struct is a type. But really, each property is driving the data type. Like ultimately, that's what needs to be adhered to for anything that you're working with. So you're still only at the primitive level of the data type, which is good. That's good. We need that. But the protocol is interesting, not only because it gives me an escape from having to use inheritance, period, which I love that, but also the fact that it's checking for the type, sure, but in addition to that, the thing that you're saying must conform to it must also have the same properties and methods, assuming you have methods in your protocol, which we do. We have 2 here. And they have to conform to the signature. And that's really this I really like, because this means I can write protocols to represent all my different transaction types that I want to occur. So like basically any interaction hierarchy I can define as a protocol, and I never have to worry about some kind of unexpected interaction. And even if I come across a bug, I know the first place that I can look, because if something is happening, if there's some transaction, well, I call them transactions. I shouldn't. That's SQL jargon. What am I trying to say with transactions? I don't know what the equivalent would be. I guess an execution or a run. Yeah, I guess an execution though would be the thing, or really an initialization of an object would be the closest thing. But whatever, it doesn't matter. The point is, even if there was a bug, you would know where to look. You would know where to start, because your protocols, if it allowed it to run, that means that it's conforming to your protocol. So you need to go check your protocol first. And so I really like this, because now you have, if you do everything on a protocol basis, now at the very least you always have a place to start in terms of debugging. Well, provided it's some kind of issue like that, right? It could be something else. But I'm just saying, for the most part, I would think that, at least in my experience, it's almost always some kind of issue with how the types are interacting or not interacting, or interacting in an unexpected way, based off maybe you have multiple transformations. So anyway, my point is, I really like this, and this is I'm curious if any other programming languages, let's just go check that out. We're going to have fun with it today, because my girl works all day, so I ain't got nothing to do. So I don't start working again until the end of July, the 1st of July, which was my choice. I wanted to finish this stream. I did not want, the last thing that I wanted to do, because we've already gotten so far into it, was to stop streaming, just because obviously I would be working. I've been doing this at 11. But yeah, not to get too sidetracked, but yeah, just remember, you always have leverage too. So if you're negotiating for a job or whatever, don't forget that you have every much a right to negotiate when you get that offer letter, emailed to you or whatever. Don't just sign it and think, it's great, thank God, got a job, that's great, that's good. But that doesn't mean you just throw out all your leverage too. So just think about it, that's all I'm saying. But I'm blessed, so I'm happy. But that's the reason I'm telling you guys that, because it's relative to this stream. I wanted to finish doing this for my own sake. Just for my own sake, I wanted to finish this out. And that is just about the amount of time that I need. Because then, at least once we get through the Swift language proper, right? Like once we at least give this book, the Big Nerd Ranch Guide, a solid go, no pun intended, we'll be able to work and do side projects and things of that nature. And hopefully that having that basis and having finished that all the way through without long breaks is going to be a benefit. Okay, so then what was I gonna, I'm curious what other languages do. Any other languages have protocols akin to Swift? Blueprint. That was the word that I like that. So what's funny about this is I can't speak to Java or C#. Never touched it in my life. Don't have any desire to. But TypeScript really shouldn't be. It really shouldn't be here. I've just become more and more jaded. Like my experience with web dev, especially TypeScript in general, to summarize in just a sentence, is more trouble than it's worth. Because it's not even fucking typed. It's not typed. It's not typed. It's just not. There's no type safety. What do you mean TypeScript? They should have just called it ceremony. JavaScript ceremony. JavaScript boilerplate. JavaScript devs want autocomplete when they're writing syntax, so let's call it TypeScript. That's what they should have called it. Fuck out of here. Anyway. Yeah, Go interfaces, they're not as powerful as the Swift protocols, but yeah, those were probably the closest thing I've experienced, but not quite that. Or not as expressive, I'll say, but you can still get the general shape. Python, abstract base classes. Yeah, whatever. I mean, look, brother, Python or JavaScript, like if you're coming around telling me there's anything being enforced beyond your editor in TypeScript, JavaScript, Python, Elixir, sit down, brother. These are type safe languages we're talking. All right. Oh, this is cool. Rust traits. I've heard about these. I've heard about these a lot. Rust traits are similar to interfaces and protocols. Trait drivable function drive ampersand self. Struct car. Is that like their $? Struct car implements drivable for car function drive function main. What the hell? Do I like Rust? Nah, there's no way I like Rust. Okay, so that code did look kind of nice though, but I'm good. I wonder when programming language. On May 15th, 2015, the group finally released the first version, and groups of Rust nerds gathered. What is this website? MIT Technology Review, and groups of Rust nerds gathered for parties worldwide to celebrate. Get destroyed, Rust nerds. All right, so we'll get back to it. That's awesome. Okay, so let's start back with conformance. Where were we? Protocol conformance. As noted earlier, the syntax for protocol conformance looks exactly the same as syntax used to declare classes superclass, as seen in chapter 15. This brings up a few questions. What types can conform to protocols? Can a type conform to multiple protocols? Can a class have a superclass and still conform to protocols? All types can conform to protocols. You made a structure called department conform to a protocol. So that was this syntax here. So just like a type annotation, is that what they call it? declaration, just like a type declaration. And then we saw the comma syntax, so it can adhere to multiple, because this is also a protocol, but it's purple because it's standard library stuff versus our custom defined tabular data source protocol. Okay, enums and classes can also conform to protocols. The syntax for declaring that an enum conforms to a protocol is exactly the same as it is for a struct. Yep. The declaration of the type is followed by a colon. Pardon me. By a colon and the protocol name. Classes can be a little more complicated. We will get to them in a moment. It is also possible for a type to conform to multiple protocols. One of the protocols defined by Swift is custom string convertible, which types can implement when they want to control how their instances are converted into string representations for use in debugging. Other functions like print will check whether the values being printed conform to custom string convertible when deciding how to display them. Custom string convertible has a single requirement. The type must have a gettable property named description that returns a string. So we took a deep-ish look, more for my own edification, but of where the hell that was coming from. And the answer was much like all the other answers, which is it's part of the standard library, and custom string convertible is just a protocol. It's a protocol defined on the string type. So you always have access to it. You always have access to this, and then by virtue of that, we also have access to this, which they showed us, the string describing method. Or I thought it was this one, maybe it's not. String describing. Maybe that was in Monster Town. Yeah, maybe. Anyhow, this is what they're talking about. So by saying that the struct department here, this is a protocol. So we're saying that the struct department has to conform to these two protocols. The only requirement to adhere to custom string convertible is that there's a property named description of type string. And so that's just a way to, whenever you call string describing, it's a way to tell it's a way to tell your program how the string should be interpreted, or how it should be converted, displayed, handled, as opposed to, let me see if we have, like if you were to just stringify this, you would literally get back the entire department name, parentheses and all. But when we run this, we can see the difference. So instead of just stringifying that whole thing, which wouldn't be very useful, Command-Shift-Enter. Xcode's gotta wake up. Wake up, brother. Got a big day ahead of you. And so instead we get this department engineering, which is how we wanted it represented here in the return, which is under the property description. So that's how we conform to the protocol. But in terms of seeing what it is, you just have to, if you hold Option and click on it, it'll just pull up the documentation for it, and you can see the requirements for it. Now, what I did want to look at, they have it under not conversion, but string representation. Yeah. Okay, protocol, custom string convertible. Types that conform to the custom string convertible protocol can provide their own representation to be used when converting an instance to a string. The string describing, that's what it was, an initializer, not a method. It's an initializer, which is still a function, but still. So the string describe, is the preferred way to convert an instance of any type to a string. Notice the emphasis on any type, any. If the past instance conforms to custom string convertible, the string describing initializer and the print function use the instance's custom description property. So it's just, there's a check that's happening behind the scenes. So long as we have the property named description of type string, it will pick up on that and it will use that representation instead. Now I think well, I won't go too far gone. We'll get back to it, but I'll read through this here. So conforming to the custom string convertible protocol, add custom string convertible conformance to your custom types by defining a description property. So there's that requirement there. So we can see it in this example. For example, this custom point struct uses a default representation supplied by the standard library. So I guess the takeaway for that, like when I look at this, is that whether you add it or not, you're still making a decision, basically. So I would imagine for most things, because I guess I'm just thinking if it has anything to do with the user's input or anything that we would want to display to the user, like basically the only thing you wouldn't want to have this description property on would be like your implementation details that the user would never really need to know about. But I don't know, I'm just saying there's going to be a lot of it, at least for my purposes, because my application is going to deal with customers' inventory. So there's going to be a ton of inputs, a ton of outputs, and for all of the inputs, in some form or fashion, I'm going to need to represent that back to the user. So yeah, I'm going to have this description property everywhere. So, but yeah, I mean, I like that it's not, I kind of like the idea that even though it is yet another thing that you kind of just have to know, I mean, it's not necessarily one of those things where it's obvious by reading the code. But still, I mean, that's okay. I'm okay with that for this purpose, because at least they're giving you a way to, like, that's pretty straightforward. Pretty straightforward way for you to control how your strings are represented. So I like that. They don't force you to do it a certain way. They just force you to describe how you want it done. And I'm into that, brother. All right, so topics, instance properties, var description, a textual representation. Oh, that's literally it. Okay. All right, so let's go back then. I just wanted to read through the guts of it. Now, if I do wish there was, I guess it makes sense that it's not there, but I wish we could see the source code straight from here, but you could just go to GitHub. Matter of fact, we are going to go to GitHub. I want to see it. I want to see what it looks like, because it'll help me close out that part of my brain so we can move on. GitHub, not SQL, Swift. Huh? What? That is not Swift. What are you talking about, brother? Here we go. Let's go look at documentation. Come on, bro. Swift. There we go. All right. Where? API notes, bindings, docs. Oh, stdlib. You know it, brother. Linker, private, public. Public, I assume. String processing. I could probably just search from this point. So we're looking for dang it, what was it called? Custom string convertible. Okay. We haven't even seen these yet. Uh-oh. Oh, well, it's pretty obvious what that means. Public protocol, custom string convertible, var description, string get. Does that? In this file extension. Okay, well, maybe. Oh no, maybe that's not exactly what I want to look for. Let's do the string describing. Or maybe just describing. Shouldn't include extra stuff if the class is private. Expect equal. Expect equal. Yeah, I don't know. I don't know what that means yet, so too soon, brother. All right, we'll just get back to basics. All right, so now we're back. Modify department so that it conforms to both tabular data source and custom string convertible, using a comma to separate the protocols. Okay, we did that part. So we did that. That's this syntax here. So if you want to assign multiple, you just comma separate right there, just like a type. So then, and we did end up printing the department. Yeah, so we got that far. Custom string convertible lets the developer of a type describe instances of the type to other developers who will use those instances in their code. Lets the developer of a type. Yeah. So is that not... I'm not sure I follow the intended use then. Merely implement, you must declare. When you pass print an argument of a type that is not custom string convertible, the output is generated by the compiler and is often not very useful. By making your types, especially types that model data, conform to custom string convertible, you give other developers the important information about that type that they will need to know when printing its instances. You give the developer the important information about that type. Okay. Finally, classes. Okay, well, before we get into classes, I want to ask about that because it seems like a good thing to know. So in SwiftLang, what is the intended use of of both the custom string convertible what is the use case of both the custom string convertible protocols? Description property is the use case of both the and the please provide examples of defining and using. Just a little confused. I mean, I get what it does, obviously, but I really want to know more the convention, because I don't know what's convention in Swift ecosystem, but like, is it? I guess my main question is it mainly for library authors to play nice with the developers that will use those libraries, or is there some kind of end user, you know, application developer use case in that sense? The custom string convertible protocol is used to provide a custom textual representation of a type. Types that conform to this protocol must implement a description property that returns a string. This is useful for debugging, logging, and providing a human-readable representation of an object. Okay, well, there you go. Yeah, debugging, logging, okay. Oh, I see. So so you could, you would use your description to return all of your properties, which seems overly obvious now, but hey, brother. Okay, no, okay. Yeah. But what else? In this example, the person struct conforms to custom string convertible and provides a custom implementation of the description property, which is here, return person. So, but I mean, this is literally the string, so you can literally choose the format in which it comes back. Ooh, you know what's neat? You could even, well, I wonder if you could return some HTML. As a person's printed, it uses, okay. String describing. The string describing initializer creates a string representation of the given value, which can be of any type. If the value conforms to custom string convertible, it uses the description property of that type. If the value is nil, it returns nil. This is particularly useful when you want to convert an optional value to a string without force unwrapping it, or when dealing with heterogeneous collections. Whoa, slow down on the big words, brother. So struct car custom string convertible. Okay, and then let car equal an instance of car, with the make being Tesla, model being Model S. Let optional car of type optional car equal car. Equal car. Let optional car of type optional car equal car. Let nil car equal optional car equal nil. Oh, because it's an optional, so it can equal nil. Weird. Print. So optional car is equal to car. Car is equal to an instance of a car. So why is this? Let optional car, print optional car. In this example, string describing is used to convert both a non-optional and optional car instance to a string. For the non-optional instance, it uses description property defined in custom string convertible. Right. For the optional instances, it handles them appropriately, showing optional for a non-nil optional. For a non-nil optional and nil for a nil. Okay, so yeah, I don't know. I mean, I get it. I get what it's doing, but I just don't see why. Maybe you wouldn't, but why would you do that if you can see the code too? Or maybe you can't see the code. I don't know. It's weird. These tools are powerful for making your types more readable and for working with optional values in a safe and concise manner. Yeah, but what is the value in this output? Would I use this? Indicates the variable is an optional containing a car object. This output provides a clear indication that the value is not just a car object. So it shows you whether a variable is an optional, whether it contains a value or is nil. Okay, I can see that. Yeah, for seeing optional in the output helps developers quickly identify that the value is an optional. This can help in debugging scenarios where you need to know if a variable has been initialized or is still nil. Okay, so that's, yeah. You avoid force unwrapping optionals, which can lead to runtime crashes instead of you get a safe readable. So debugging, when printing values to the console for debugging purposes, it helps to know the exact state of your variables, especially when dealing with optionals. When displaying optional values in the user interface, you might want to show a placeholder or message indicating that a value is missing or not yet available. UI label might display car nil. Okay, good. Here's an example, a more complete example illustrating debugging and logging. Cool. Okay, so there is our conformance, right? Yeah. Our description property. Here's the same example. Our three constants. Okay, debugging, print this phrase, string describing optional car, and that prints that same output we saw, optional, yeah. I guess in this sense it's a little more overly obvious because of the example, but maybe, I mean, obviously they wouldn't be named this, you know, named so obvious, so maybe that's why it's not really resonating with me here in terms of like what the use is. But either way, that one little sentence up there made sense, and that is good enough. So log, oh, you can car status, log car status optional car. Yeah, okay, let me just save this because that was enough a variable. Booyah, insta-give. Alright. Okay. Now on to classes. Finally, Classes can also conform to protocols. If the class does not have a superclass, the syntax is the same as for structs and enums. If the class does have a superclass, the name of the superclass comes first, followed by the protocol. I see. Ugh. Try not to yawn. Okay. Protocol inheritance. Wait, so they're saying, just to be clear, so if we have a class grass, and we wanted to give it a protocol and a superclass, it would be superclass first and then protocol 2, so on and so forth. So via sequencing, we can use both. Protocol inheritance. Swift supports protocol inheritance. Boo. A protocol that inherits from another protocol requires conforming types to provide implementations for all the properties and methods required by both itself, I hate this, and the protocol it inherits from. This is different from class inheritance, which defines a close relationship between the superclass and subclass. Fuck off, Nat. God, it's so fucking annoying. Required by both itself and the protocol it inherits from. This is different from class inheritance. It doesn't really seem all that different, which defines a close relationship between the superclass and subclass. Protocol inheritance merely adds any requirements from the parent protocol to the child protocol. Seems the same, brother. For example, modify tabular data source so that it inherits from the custom string convertible protocol. Okay. Prove me wrong, brother. Okay, so up at the top. And what are we doing? Protocol, tabular data source. Oh. Oh, God. Yeah, pardon me. Custom string convertible. Now, any type that conforms to tabular data source must also conform to custom string convertible, meaning it has to supply all the properties and methods listed in tabular data source, as well as the description property required by custom string convertible. Interesting, but we don't have to define it in the protocol itself, tabular data source. It just comes along for the ride. Okay. Yeah, I mean, I shouldn't complain. That is actually cool, because that means now you can just write one protocol for all of your, you know, whatever your most common requirements would be in a given module, or even maybe even program wide, like for the whole program. So that's cool. And yeah, I shouldn't hate on that, because I like that. Okay, I like it. I admit it. I really like it. Now, any type that conforms to tabular data source must also conform to custom string convertible, meaning it has to supply all the properties and methods listed in tabular data source, as well as the description property required by custom string convertible. Use this in print table to print a heading on the table. You will no longer need the declared conformance you added in listing 1910, nor the call to print from listing 1911. Okay, so func print table is what we are modifying. And what do you want me to do here? You want me to data source, tabular data source, print table data source. Just straight up like that, huh, brother? Alright, print. Table Cannot find it in scope, brother. And then you want me to get rid of from the struct, take out the tabular. Oh, because we're already telling it to conform at the protocol level itself. Therefore, we no longer need to tell the department to also conform to that very same protocol. Hot dog. Okay. So then, what is next? Print table. Oh, so then at the bottom, if we go capital G, yeah, baby. And we no longer need this, so double D to delete the line. Ha. All right, and now what? Run it? You want me to run it? Command Shift Enter. Oh, we got an error here. Okay. Note. Now the printout in your debug area includes a description of a table. It's not. Wait, what's going on? Cannot find data source in scope. Cannot find data source in scope. Func. Oh, data source. Huh. That might help to spell it right. There we go, brother. All right, Command Shift Enter. Oh, we need the Command Shift Y. Get our console up, and now let's rerun it. And then we get this nice little printed table. Table, department, engineering, the employee name, age, years of experience, and then our data in our nicely almost matching columns, kind of. I mean, I really just wanted to scoot it out, just one space, we would be all set. Count separator. If I add one space, what would happen? Yes. My OCD is like supremely squelched right now. Man, y'all have no idea. Okay, so protocols are allowed to inherit from. God damn, they turned the music up. Hold on. I guess it's fine. I think it's just loud on my end because I did test it, so hopefully it sounds fine. All right, so protocols are allowed to inherit from multiple other protocols, just as types can conform to multiple protocols. This syntax for multiple protocols inheritance is what you probably expect. Yeah. Separate additional parent protocols with commas. Or no, it is separate. Separate additional parent protocols with commas like so. Yeah, so we got that. I mean, it's literally the same. So then we just need to remember in the event that we use classes, which we might use final class when it's all said and done, just because we don't want to make copies of everything, so we might want to use that. So yeah, we will need to remember that. So the rule is if you're using protocols with classes, then you need to have the superclass first in the comma separated list. So superclass and then protocol, comma, protocol, comma, protocol. Blase, blase. So some of this was really when in doubt, I'll just highlight the whole first, because these are usually pretty good definitions of how those things work. Okay, so then protocols as types. Your ability to pass an instance of any tabular data source conforming type. Your ability to pass an instance of any tabular data source conforming type, like department. Okay, so like this guy. Your ability to pass an instance of any tabular data source conforming type, like department, into print table may look familiar. What was the print table again? What did we... Okay, so that was just a method. Well, hold on. How do I do the whole, is it, oh, I think it was the percent sign to go to the other. Yeah, so that's, okay, that's all one function. Okay. So, we pass in the data source. Has to adhere to that protocol, so it has a number of rows, a number of columns. Those are minimally values that you can read as defined by get, and then it has to have these two methods, and so we have an implementation of it here. Label for column, item for row. Where do we... Hold on, buddy, you gotta hide you for a sec. Okay, so there's that function. I'm just trying to make sure these are in a separate scope so I can ask the right question, because I'm in my head, I'm thinking, and this says, okay, for this function, anonymous external parameter name data source, and it's of type tabular data source, which is our protocol. So we need implementations of these two methods. Or maybe that doesn't apply to functions. I don't know, but where is label for column? Oh. Okay, but where's item for row? Item for row. Okay, my bad. Oh, because they are methods, so they would be after on the caller, on the dot notation. All right, my bad. Okay. Yeah, that's interesting. So it really, I mean, it's a good thing straight up, but I'm just saying it just needs to have an implementation of it. Period. But maybe still not. I don't know, just I was thinking initially maybe this becomes a little too restrictive, but really it's not, because let me just ask. I'll just fucking ask. I just want to make sure I'm thinking about this before I move on in the correct way. And they did tell us, maybe just by reading it again, it'll be, what page are we on? Inheritance, 479. Okay, I just want to go back to the initial definition. A protocol allows you to define the interface you want a type to satisfy. A type that satisfies a protocol is said to conform to. You can think of a protocol like a contract that every conforming type agrees to. This allows you to code against a contract without concerning yourself with specific types. Define a protocol. That wasn't it. Okay, here we go. The tabular data source protocol states that any conforming type must have two properties: number of rows and number of columns. The syntax get signifies these properties can be read. It must have two properties. So I guess my question is, I'm not sure. We might get there. Like, they just have to be involved, like, to any degree? I guess that's really my question. Yeah, we're gonna ask it, but I'll finish reading this just in case there's some knowledge that escapes me. The syntax get signifies the properties must be read. If the property were intended to be, fuck off, dude, holy shit, intended to be read right, you would use get set. Dipset. Note that marking a protocol property with get does not exclude the possibility that a conforming type might have a property that is read write. Yeah, I get that part. This is also why the var keyword is always used rather than let for properties in a protocol definition. Finally, specifies that a conforming type must have the two methods listed with the exact types that are listed. So I see the methods part. That's what we got. Or no, even that's not it. Where's the label? For item, padding needed, column widths, item.count. Oh, there it is right there. So there's the label. And then item 4. Number of columns. Number of rows. Okay. Alright, yeah, so let's just ask it that. Generally speaking, given the below code is to what extent does the dictate the use of properties and methods? Do they only present used once in a given conforming or not a type, but this would be more like an object. Or no, it would be a type. And methods depend on whether the conforming type needs to meet the requirements defined by the protocol. By implementing the required properties and methods. They must be implemented according to the protocol's requirements. Yeah. The protocol only dictates that these properties and methods exist. I realize I didn't give it the code, but that's okay because it caught what I was saying. The protocol only dictates that these properties and methods exist and are implemented in a specific way. It does not dictate how many times or in what context. Okay, so that was my question. So it is still pretty, I mean, it's nice that it exists because it's not foolproof still. I guess in the back of my head, that's really what I was thinking, is that there's still so much room for, I guess, for error, but I shouldn't look at it that way, or I don't want to look at it that way. Although it's true, but that's true of any language. So those kind of points, you know, I hate making those kind of points. If it applies to everything, then what are we talking about? But yeah. So blueprint is very, very appropriate. Okay. So, well, even not, I mean, I don't know. More like, it really should be more like, you really shouldn't call it a blueprint because it doesn't dictate, you know, a blueprint tells you the design of something, but this isn't doing that. This is just dictating the presence of things. So it's really more like a grocery list, a checklist, you know, like, hey, these things just need to be like in the cart somewhere, but it's not dictating how you implement them or how many times you use them, which I think is a bigger thing. Yeah. Okay. Yeah, okay, present's good. They used a word that resonates with me, so now I feel validated. Summary, presence, the properties and methods defined in a protocol must be present in any conforming type. Okay. All right, so that's a good answer. Matter of fact, I'm going to, I like that answer quite a bit. Ooh, can I say, I think I can. Oops, not that. I guess I don't need to do that. I'll just put it on here. I lost my one viewer yesterday by going into an ad for board mix, so I won't do that again. I apologize, but I swear I'm just dropping it on the board. I'm just dropping it here. I'm not even gonna talk about it. Where's my block? Oh, there it is. Like, where the hell is it? Block. And this was understanding protocol conformance. I think I'll wait until we finish this book, but I will share that link with you guys, and I'll clean up the board a bit, and then all the little key points that we cover, like all my highlights effectively, will be on that board. You know, just to give back, brother, just to help. It'll help me too, though, honestly. It'll help me too, because there's a ton of information. Now, that being said, why doesn't this go away? Come on. Whatever, it doesn't matter. Y'all know what time it is. If you need to go take care of anything, go do that now. We're gonna have a brief intermission. See you at, what time is it? We're killing it today. Getting the hours in. 12:57. 1:20 CST. We got to get a banner, Jared, because this is for the birds. All right, y'all. Be right back. I have to go take care of something. Be right back.
can see that.
Just in time, baby. Oh yeah. Oh yeah, oh yeah. Hashtag never late, brother. Alright, come. Here we go. So let me shrink this down. Okay, where were we? Why is this here? Oh yeah, this was on my legs because it's freezing out here. Alright, we were make department conform. Oh yeah, okay. The syntax for conforming to a protocol is to add protocol name. No, we read this. We were ahead of this. Make print table, we wrote that. We're on 4. Yeah, here we go. Print department. We were down by print table. Data source, we got there. Okay, here we are. Yeah. All right. Protocols as types. Here you assign an instance of department into a variable of type tabular data source, which is 51. Okay. Oh no, I skipped the let part. Okay. May look familiar. It is an example of. Okay. Protocol as types. Your ability to pass an instance of any tabular data source conforming type, like department, into print table may look familiar. It is an example of polymorphism, similar to the subclass polymorphism that you learned about in chapter 15. Polymorphism. In computing, the ability in programming to present the same programming interface for differing underlying forms. The ability in programming to present the same programming interface for differing underlying forms. Okay. As with the subclassing example, you can declare a variable of protocol type. Print table. All right, so how do I get this to go away? It's really annoying. No results. Got it, brother. Shit. Shoot. Let operations, let operations data source of type tabular data source, which is a protocol. So we're saying this constant will conform to tabular data source protocol, and it's equal to department, which is a struct that also conforms to the tabular data source protocol, as evidenced on line 51 above. And we're going to pass in, for the department name, operations. Okay, so we're creating an instance of the struct department. Okay. Yeah. Here you assign an instance of department into a variable of type tabular data source. As you might expect, the compiler will now insist that you only access properties and methods required by the tabular data source protocol. I'm not getting anything. It must be jacked up because of this stupid... I guess I'll just let me kill it real quick. Command Option Escape. For some reason, Xcode just won't close any other way. So, you know, that's fun. But It's not actually fun. I wish it would stop doing it, but what are you gonna do? Get out of this. Good old macOS window management, brother. Nothing better. Best in industry. Not really. Where's my other? Yes, exit. It's so goofy, man. Oh, it's on the wrong side. Son of a bitch. Oh my god. Alright, tile left. Tile window left. Okay. Sorry about that. Bro, drag the fucking... Oh my god. I hate macOS. Okay, protocol. Where were we? About to lose it. Here you assign an instance of department into a variable of type tabular data source. As you might expect, the compiler will now insist... yeah, so let's run it, see if I get said error. Oh, I guess they're just describing what it will do. Okay, as you might expect, the compiler will now insist that you can only access properties and methods required by the tabular data source protocol on operations data source. Okay. Makes sense. Yeah. This is because the compiler knows that you might replace the department instance stored in the variable. You might replace the department instance stored in the variable with an instance of another type that conforms to tabular data source at any time. So it would be unsafe to allow you to access department only properties like people. Let's read that again. Okay, we assign an instance of department, department being oh no, we have a variable department and a struct department. So we're talking about the struct, the type. Yeah. So an instance of department into a variable of type tabular data source. Yeah. As you might expect, the compiler will now insist that you can only access properties and methods required. Only access properties and methods. That's a bit confusing, but we'll read on because yeah, we'll keep going. I'll come back to that. This is because the compiler knows that you might replace the department instance stored in the variable, but it's a constant. Why? You might replace the department instance stored in the variable. Yeah, that doesn't make any sense to me because it's a constant variable with an instance of another type that conforms to tabular data source at any time. So it would be unsafe to allow you to access department only properties like people. Yeah, I really don't understand that. The as keyword and its forcible and conditional variants are also available for casting between protocol types and the concrete types that conform to them. Declare a new variable of type tabular data source to put a copy of your engineering department into. Man, what? I feel like I've been paying attention, but I mean, they did say this was the advanced Swift section, so I guess that's to be expected, but we're going to ask and understand it nonetheless. So in Swift, given the below code and excerpt, please expound on why, how we are able to replace a value in a constant. So there's the code. All right, in Swift, when you assign an instance of a type that conforms to a protocol to a variable or constant of that protocol type, you are working with the abstraction provided by the protocol rather than the concrete implementation. Let's break down the scenario described in the given excerpt. Let operation, okay, well, that's our code, yep. Declaration and initialization. Operations data source, so the constant, is declared as a constant of type tabular data source, which is the protocol, so it must conform to it. It is initialized with an instance of department, which conforms to the tabular data source protocol. The type of operations data source is tabular data source. This means you can only access properties and methods that are defined in the tabular data source protocol. This means you can only access properties Oh, okay, so that still doesn't explain the other part, so let's keep going. So then, even though operations data source is actually an instance of department, the compiler restricts access to only those features declared in tabular data source. This is because, from the compiler's perspective, operations data source could be replaced by any other type conforming to tabular data source at any time. This is because the operations data source this is because from the compiler's perspective, the variable, or the constant could be replaced by any other type. What? That's not the type. It's the fucking constant. What do you mean? Could be replaced by any other type conforming to immutability and reference types. In Swift, the let keyword makes a variable or constant immutable, meaning you cannot change the reference to another instance. However, if the type of the constant is a reference type, such as a class, which it is not in this case, you can still modify the properties of the instance it references, as long as those properties themselves are mutable. Replacing a value in a constant context. The key point to understand that in this context, we are not actually replacing the value of the constant itself, but rather working with the references, with the reference types mutability. immutability of operations data source. The constant operations data source cannot be reassigned to reference a different instance. Okay, so are you telling me... Damn it, now I want to... don't want to lose that there, but okay, in Swift are protocols reference types. However, whether a type conforms to a protocol is treated as a reference type. However, whether a type that conforms to a protocol is treated as a reference type or a value type depends on the conforming type itself. Value type. Structs and enums and Swifts are value types. Yes, when you assign or pass a value type, you get a copy of its data, for example, of a struct. If a struct conforms to a protocol, it remains a value type. Reference types. Classes in Swift are reference types. Right. When you assign or pass a reference type, you are passing a reference to the same instance. If a class conforms to a protocol, it remains a reference type. Okay, protocols can be used with both value types and reference types. The protocol itself does not enforce value or reference semantics. Okay, so then that doesn't still seems wrong what you're telling me here. Okay, so the constant operations data source cannot be reassigned to reference a different instance. Okay, that is irrelevant because it's not. It's a value type. It's not a reference type. Because operations data source is of type tabular data source, to access department specific properties, you need to cast it back to department using the as or as keyword. What? Okay, but even department is a struct. It's not a class. It's not a reference type. And even in the fucking thing, it's a let. It's a constant. It's... I could maybe understand if that was a var. Did I type it wrong? Let's go back to... No, it's right there. Let name. Alright, we'll just keep going because maybe they get us there. Unless I'm missing something. Tabular data source. I don't know, brother. And then here's the department struct. So that's a value type. Yeah, I don't get that. Okay, let's just reset. Fuck it. I don't know what to say about that. Here you assign an instance of department into a variable of type tabular data source. As you might expect, the compiler will now insist that you only access properties and methods required by tabular data source protocol on operations data source. You can only access properties and methods required by. This is because the compiler knows that you might replace the department instance stored in the variable So I guess since maybe it's just confusing because the struct is department, but the variable is also department. So in the same sentence, they're referring to the two different departments. Because this is a var, that has to be it. I don't fucking That has to be what they mean. Sorry, still going through puberty. Okay, so this is. Yeah, that has to be what it means. This is because the compiler knows that you might replace the, although they did capitalize it, the department instance stored, or I guess that makes sense because that is what's in the variable little lowercase department. It is department, but we might replace department in the I think I get it. I think it's sinking in. Stored in the variable with an instance of another. And they're saying that because I can do that because that is my type here. So that would be okay. I get it now. I got there. I was looking here, but they're talking about replacing this, and this is a variable. All right, my bad. Okay, so the as keyword and its the as keyword and its forcible and conditional variants are also available for casting between protocol types and the concrete types that conform to them. Declare a new variable of type tabular data source to put a copy of your engineering department into. Okay. Let engineering data source equal department as equal department. What? Because the compiler can verify that department's type, department, the struct, not the variable, conforms to, so they're saying because it can confirm that, wait, so let's go down. Where did we give it the type first and foremost? Because the operation, declare a new variable of type tabular data source to put a copy. Because the compiler can verify that department's type, department, so that's through the type inference. It must be because we don't give it a type here, but we say it's equal to department. And then if we look at department, that's equal to the struct department, which finally actually has a type, and it's the protocol tabular data source. So they're saying because the compiler can verify that department's type, department, conforms to tabular data source, which is exactly what this says here. This is a safe cast. Okay. And the compiler will infer the type of engineering data source to be tabular data source. Right, okay, so it is inference. Now it's getting there, and that makes sense, but I still I'm not catching with the as use here. Because if inference is handling it, why do I need that? What is it? And couldn't that also change? The compiler will infer the type of engineering data source to be tabular data source. Casting a variable of type tabular data source to be of type department would be unsafe. since there might be other types that conform to tabular data source. I mean, that part makes sense, because if the type you're assigning itself also, like in this case, struct, so if you're trying to give it a type department, but that type itself conforms to a protocol, then just use the protocol. That part makes sense, but still, hopefully they explain the as, like what's the point? So department would be unsafe since there might be other types that conform to the tabular data source, and the compiler would not know which of them is in the variable at any given time. Last, the is keyword can be used to check for protocol conformance. Conformant, yeah, is that what it said? Conformance. Okay, so beneath, yeah, make it make sense, brother, because I let Mikey equal person. Person is yet another struct, so this is a value type that we're using. And for the name argument, we'll pass in Mikey, age 37, dang, old brother, years of experience 10. Mikey is Mikey is tabular data source. False. Because Mikey is equal to person. We go up to person, and it is not conforming to tabular data source. So it's false. Okay, but I mean, I get that, but okay, so here you ask the program, hey, is the value stored in this variable of a type that conforms to tabular data source? The person type does not, which is reflected in your sidebar, false. Yeah, okay. It is important to remember that when you declare a variable or function argument to be of a protocol type, you are stating to the compiler the actual instance inside this variable may be of any type that conforms to this protocol. Well, y'all should have started with that. Yeah, that's not how it was explained up front, brother. Which okay. Yeah, it is important to remember that. Shucks. Okay. Okay. The actual instance inside this variable may be of any type that conforms to this protocol. Get the fuck out of my face. I'm so sick of that fucking bug. I'm just going to turn on a big ass fucking vacuum in here and run it 24/7. I don't care how loud it is. All these little shits get sucked up. Okay, the actual instance inside this variable may be of any type that conforms to this protocol. Interesting. And an instance of a different concrete type that conforms to this protocol might be used instead at any time. Wow, they really, okay, so the actual instance inside this variable may be of any type that conforms to this protocol, and an instance of a different concrete type that conforms to this protocol might be used instead at any time. So it's not even just the ones that have this explicit conforms to syntax, it's also any type that also shares these properties and methods. Fucking, ooh, I'm gonna get his bitch ass. How the fuck did he get away, dude? When did they get so fast? It's just one net. It's really pissing me off. Okay, I'll get you, brother. Do it again. Okay, so we gotta... You can't just move on from that. Man, dude, just shook my whole world. Okay, so... I understand what it's saying, but I want to make sure this part is... I want to make sure I get this part of it explicitly. So, give me this. Alright. Based off the below code and excerpts on SwiftUI, please expand on the please expand on the meaning of the to be replaced by concrete that adheres to the protocol. What does this mean, and what would a before after example look like? I don't really like that it lets you do that, because to me that's I don't know, it kind of undermines the purpose of protocols. What do you mean it doesn't have to conform to it? Yeah, I don't like that. What does it mean for protocol to be replaced by? When you declare a variable or function argument as a protocol type, you're essentially saying that this variable can hold any instance of any type that conforms to this protocol. This provides a level of abstraction that allows for flexibility and modularity in your code. That part I get and I like, actually, because that's fine, because that was my misunderstanding. So that part, okay, great. For example, consider the following protocol. Protocol, tabular, oh yeah, we give it to them. Yeah, so that's the one we've been working with. 2 methods, 2 properties, okay? Any type that conforms to tabular data source, what are the hiccups, must implement the required properties and methods. Any type must implement the required properties and methods, which we know a better definition now to be effectively that they just need to be present. The properties and the methods. They just gotta be there somewhere in that struct, in that enum, in that class. Cool. And so here's an example. This adheres to the protocol. Therefore, we got the 2 properties from the protocol here, and the 2 methods, label and item 4, are implemented. That's it. That's all it takes to conform. So that satisfies that. Before and after. Before, using a protocol type. When you declare a variable of a protocol type, you are stating that any instance conforming to the protocol can be assigned to this variable. So we have our data source, tabular data source. Data source is equal to simple table, number of rows 3, number of columns 3. Okay. Here, data source is declared as a tabular data source. Initially, it is assigned an instance of simple table. This means that data source can be replaced with any other type that conforms to tabular data source. Okay. struct another table, so value type conforming to the protocol, data source equal another table, number of okay, yeah, that makes sense. Now data source has been reassigned to an instance of another table. This showcases the flexibility offered by protocols. Okay, I get that part. That makes sense to me. After using a concrete type. If you were using a concrete type directly, you would lose this flexibility. Var data source, simple table. Data source is equal to attempting to assign a different type conforming to the protocol would result in a compile time error. Attempting to assign a different type conforming to the protocol. Attempting to assign a different type conforming to the protocol will result in a compile time error. Data source equal another table, error cannot assign value of type another table to type simple table. So okay, can't do that because this has to conform, because this type itself conforms to the protocol tabular data source. So I get why that would be an error, but or maybe I don't. Data source equal cannot assign value of type another table to type. By specifying data source as simple table, you restrict it to only ever hold instances of simple table, which removes the ability to easily switch out the underlying type for another conforming type, which removes the ability oh wait. Okay, so okay, that didn't answer my question then, because that's not what the book is saying. Variable or function argument as a protocol type. You make your code more flexible and reusable. It allows for any conforming type to be used interchangeably, promoting a modular design. On the other hand, using a concrete type directly binds the variable to that specific type. Okay, let's go back to what the book said. Or wait, it's in that chat. I didn't ask my question well enough. So they're saying this is what we're telling the compiler. The actual instance may be of any type that conforms, and we got that. And an instance on a different concrete type that conforms to this protocol might be used instead at any time. Explicitly on this passage. The book is saying this is what we are telling the compiler. It sounds like it is saying you could replace. Ah, he's back, little fucker. It's too far. I need one of those zappy things just for that one bug. It'd be so worth it. Okay, it sounds like it is saying you could replace the, what was it? Department. Yeah. I use the value with a type that has all the properties and methods from the protocol present, i.e. satisfies the requirements but isn't explicitly written to conform to the protocol itself. It just happens the requirements. Is this correct? Can indeed be a bit confusing. Let's clarify what it means and address your interpretation. What the passage means. When the book says an instance of a different concrete type that conforms to this protocol might be used instead at any time, it means that any instance of any type. It means that any instance of any type that explicitly conforms to the protocol can be assigned to the variable. This does not mean that a type can just happen to satisfy the protocol's requirements by coincidence. The type must explicitly declare its conformance to the protocol. Okay, good. Explicit conformance required. In Swift, for a type to be used as an instance of a protocol type, it must explicitly conform to that protocol. This is done by declaring conformance to the protocol in the type's definition. Simply having the required properties and methods is not enough. The type must state its conformance. Okay, good. So that was my biggest concern. So I guess now I kind of understand what it's saying. I guess now what they meant by concrete type was one that had it explicitly written out, because in this case, like our two examples here, just ahead of them saying that, are using type inference. We're not explicitly telling it. Let me reread it and see if that's if that's true. It's important to remember that when you declare a variable or function argument to be of a protocol type, you are stating to the compiler the actual instance inside. This may be of any type that conforms to this protocol, and the actual instance inside this variable may be of any type that conforms to this protocol, and an instance of a different concrete type that conforms to this protocol might be used instead at any time. So do we have one? Well, I guess they're just saying it could just be changed to do this. Like, so right now we're using type inference on line 104 for engineering data source, but it could just be that. Yeah, I know, brother, but I'm just trying to make a point here and you jamming me up. Mickey, there. So that's what it's saying. Okay, I just got to make sure, brother, because it's a little. I know I'm a bit OCD, so maybe that's partly my issue as well. But when you keep changing a concrete type now, what's concrete type? Let me do a search on that, brother. We ain't even. What's a concrete type? So you got to be you got to be flexible with your ability to learn, because people won't always keep it. It won't always come at you in a uniform fashion, which is definitely true. I know that, but still, we should question things, but I think I get it. Yeah, Shiza. Okay, good. So protocols are still Ebert and Roper. What happened to those guys? Did they die? I know they've been around a hot minute. But either way, 2 thumbs up. Okay, so protocols, cool. I feel like I get that part now, so that's good. So, actually, matter of fact, let me this is saying replace with an instance of an explicitly conforming. That's what they should have called it. I'm just saying. Instead of a concrete type, an explicitly conforming type to the protocol. With an instantly conforming type to the same protocol. Yeah. So really nothing changed at all. It was just I got mixed up with their presentation of the idea. That's all. Okay, so protocol, like, give me that motherfucking water. Protocol composition. Protocol inheritance is a powerful tool that lets you easily create, wait, where's my, turn that ticker off. Jared, what is that? You see that ticker there? Yeah, can you turn it off? Thank you. All right. Protocol inheritance is a powerful tool that lets you easily create a new protocol to add requirements to an existing protocol or set of protocols. Protocol inheritance is a powerful tool that lets you easily create a new protocol to add requirements to an existing protocol or a set of protocols. Yeah, I like that a lot. I like that whole idea a lot. That's what we were briefly speaking on earlier. Nevertheless, using protocol inheritance can potentially lead you to make poor decisions in creating your types. Okay. In fact, that is exactly what has happened with tabular data source. Oh, trick me, brother. When you made it inherit from custom string convertible, because you wanted to be able to print a description of the data source. In fairness, you did it because we told you to. Yeah, I mean, that's the problem with these kind of like gotcha kind of teaching styles, you know, because us intelligent folk we'll see something's up, we go ask ChatGPT and then start, you know, cursing at the book, you know. But still a great book. I love this book. In fact, that is exactly, we read that. There is no correlation between the requirements of custom string convertible and tabular data source. There is no correlation. Okay. Making them a poor candidate for inheritance. In a moment, you will see how you can accomplish these same results without conflating the two protocols. Okay. First, go back and fix that missing attempt to print data sources. I want to ask the Oracle just one thing, because to me, it's like, well, let's just ask it. I'm going to give it the passage, and I just want to know if it's frowned upon to I just don't understand that, because I would think you would always want, like I said earlier, for the most part, at least, definitely for any input-driven result, I would think you would want the conformance. Well, let's just go back. It's going to show us how to do it better anyway, so we'll just go from there, and then I'll ask if it's like still not very clear. Yeah, because I'm not overly concerned with what the convention is. We just want to learn the thing first. Worry about what people want you to do and what you're willing to do later. So there is no correlation between the requirement. Oh wait, making them a poor candidate. Okay, so first go back and fix that misguided attempt to print data sources. Okay. So at the very top in our protocol, we don't want to have our protocol tabular data source explicitly conform to custom string convertible here. So we now scoot back a little there, guy. Yeah, there you go. Man, it's no sun today at all, brother. Good grief. For ain't no sunshine when she's gone. Double data source, and unfortunately, department, while still printed to the console, is now anything but pretty. Oh, let's see. Okay, so first Command Shift Y. Hold on. Hot dog. Okay. That's the only thing I don't like about this Kinesis keyboard is there's no backlighting. The hell, brother? $400 keyboard, brother. That's okay. If anyone wants to sell me their spine, I'll buy it off you, brother. Get a new one installed. H30 and under. Okay, so let's see. Protocol, custom string. Unfortunately, department. Oh, yeah, so we want to see the output. So let's Command Shift Enter. God damn, what happened? Table, department, it's all jacked up. Okay. So then is now anything but pretty. Yeah, it's grotesque. The print function will use the description property if the type to be printed conforms to custom string convertible. The print function will use the description. Oh, right. They told us that. Yeah. But it falls back to a more raw representation if it does not. The raw representation that is that's definitely one that I want to save for our future reference. FYI guy on print and string representation. Kaplow. Alright, brother. Now the output from the print table function looks terrible unless the data source conforms to the custom string convertible protocol. So you need a way to make the function's parameter ensure that incoming data meets this requirement. Yeah. Protocol composition to the rescue. This syntax allows you to state that a type must conform to multiple protocols. Make the following change. Make print tables argument. Okay, let's func print table. Okay, so we're saying the data source is of type the protocol and ampersand custom string convertible. So we take the conformance, the explicit conformance off the protocol, removing the inheritance aspect, and we move it to just the input, which is data source. So now it conforms to these two protocols, just data source, no longer the entire protocol tabular data source itself. Okay. I see. So now, okay, so other things that use tabular data source that you maybe don't want to have the requirement of having that description property could do so, but we'd net the same effect for our function here, for our method. Print table is how I interpret this. So the syntax for protocol composition uses the and infix operator. New word, gotta save it. Okay, so the syntax for protocol composition uses the and infix operator to signal to the compiler that you are combining multiple protocols into a single requirement. Trying not to yawn. Here, you require that data source conform to both tabular data source and custom string convertible. Yes. Makes sense. The compiler rightly gives you an error. Oh, it did. What, brother? What's wrong? Argument type department does not conform to expected type custom string convertible. Insert. Okay, so let's. I'm not going to do that till they tell me to. Gives you an error that department does not conform. Yeah. Department being the struct. Oh, I see. So we got to add. Oops. Oh, wait, but it's there. Oh, because it's not inheriting it anymore. And we just learned that it's not enough to just be there. If it has the property. Oh, well, see, I'm learning a bunch of stuff about how this works now. I had a lot of misunderstandings because I thought if. Well, you just have to explicitly say it. So I guess you can't even use. I don't know. I'll finish reading and then I'll ask the questions because, yeah. Explicitly declare this conformance and run the playground to see that everything is back to normal. Okay, so tabular data source. Yeah. Yeah, but okay. Consider another possibility. You could create a new protocol that inherits from both tabular data source and custom string convertible, like so. Protocol print tabular data source. Yeah. You could then use that protocol as the type of the argument to print table. The type of the argument to print table. So protocol printable tabular data source, and it would conform to tabular data source and custom string convertible. No body. That's cool. And then they're saying we could just replace that with, I mean, I don't know. I guess if there was a bunch of them, that could be helpful. Yeah, I can see how that could be helpful. So printable tabular data source. Didn't like that. Oh, because of department. Yeah. Okay. You could then use that protocol as the type of the argument for print table. Oh, we did that. In short, you have a few options for ensuring that a function, let me undo that before I forget. And custom string. Okay. All right. And In short, you have a few options for ensuring that a function like print table correctly constrains its arguments. Make tabular data source inherit from custom string convertible. A solution like this could be appropriate if the two protocols are naturally related, but in this case, they are pretty different from one another. Another option, define a new protocol like print tabular data source that inherits from both. There's nothing wrong with this approach, but its real utility would be if you had additional requirements to add to the new protocol or needed many functions to use it as a parameter type. Right, yeah, exactly. Yeah. Here it would be empty and would likely be the argument type of only one function, so it would not add much meaning to your program. Compose the two protocols at the call site, as you have done. This signifies to developers that the requirement is particular to this function, is unlikely to be used elsewhere, and requires very little code elsewhere. Okay, so that's okay. I know what I said about convention, but I actually find that valuable, so I'm going to add it. I like these kinds of, god damn it, I hate this app, but I like these kinds of higher level guidance, you know, not super detailed in implementation, but telling you how and when to use something is, I mean, shoot, it's half the battle. Okay, so as with many questions in programming, there is not always a clear correct choice in this situation, okay? Or any singularly correct choice at all. All three of these approaches would solve the needs of the print table function, and all three could be the best choice for certain situations. In the future, it will be up to you to decide how to proceed. It is acceptable and even common to choose one solution and then change your mind later as you learn more about the problem. It is also possible to use composition to combine a protocol with a class. Say your person type was a class instead of a struct. With an employee subclass, you could use a composition of custom string convertible and person here, person. With an employee subclass, you could use a composition of custom string convertible and person. So this plus this description property, well, and the conformance syntax to create a function that only accepts subclasses of person that are also custom string convertible, okay? Class person, class employee, okay, so this is a little bit of an aside, but okay, so the syntax, just so I'm clear. It's the comma separation when we're writing definitions, but if we're inside the tuple, we're talking about arguments in a function, then it's the ampersand, yeah, here. It's not comma separated, it's the ampersand inside, and that tells the compiler to treat it as a single condition. So combine those two. Let me, I don't know if I highlighted that, but I should have if I didn't. Here, let me find that example real quick, because I want to keep that. Oh no, we did, it's right here. My protocols. Yeah, so emphasis on the behavior of combining multiple protocols into a single requirement. Honestly, I mean, at least for working alone, this is what I would use. I wouldn't bother doing, because again, I mean, I just don't see I mean, these are so easy to write and straightforward. I wouldn't mind having just lots of very well, very articulate, well expressed protocols, and then just combining them where I need them, compose them that way. I like that approach. I don't like the inheritance thing because it's just inevitably, when it grows, it just, then you have this challenge of separating code, and I don't want to. I'd rather it be flat and write more code. That's not a problem. I think there's too much said about being being terse is not a value unto itself. It just straight up isn't. Although nobody likes, ceremony for ceremony's sake, but also, the same can be said about readability and terseness in your code. It shouldn't just do it for its own sake. It needs to bring value. So I like that. I think that's my favorite of the implementations that we saw. Okay. Now there was a question I wanted to ask, like I said, about the what was it? It was when we first started talking. It was up here. Back to normal. No, not that. Consider the following change. Where was it at? The print function will use the description property if the type. Yeah, it was here. Just generally speaking. I think I'll just give it this passage and then ask why it's a bad idea, because I mean, if it's for debugging, I would like to have, just in my own head, my understanding right now, I would want that enforcement of having a description everywhere. If it's for debugging, I would just want it there by default. To me, that's just good practice. That way you always have insight into your variables. I mean, that sounds great to me, given the below excerpt on SwiftUI. Can you expand on scenarios where it would be an actual detriment to use custom string convertible as an inherited to my eye? It would be a benefit to have the description property present on all my variables. Using custom string convertible as an inherited protocol can seem beneficial at first glance due to the convenience of having a description property on all your variables. However, there are several scenarios where it might be a detriment. Unrelated protocol requirements. Inheriting from custom string convertible might force an unnatural or unrelated connection between protocols. For instance, if you have a protocol tabular data source that deals with tabular data, making it inherit from custom string convertible implies that every data source must provide a textual description. It should. Hell yeah, it should. For a data source, it should. However, these two concerns are orthogonal and should be kept separate to maintain clean modular code. All right, hard to disagree. What's the next one? Protocol segregation principle violation. Oh man. PSPV. Protocol segregation principle violation. What? This sounds, all right, come on, brother. The protocol segregation principle, part of solid principles. Next, comprising single responsibility. Every protocol should ideally have a single responsibility. Mixing the concerns of data representation with textual description can violate this principle, making the protocol harder to understand, maintain, and extend. But it's literally one property that you're asking to put, and it serves a very explicit purpose of giving you insight into debugging. If you're doing transformations, I mean, anyone that's written transformations at any level can attest to this. So, I mean, it would be nice to have, okay, yeah, I mean, I think it's just a matter of opinion. But I mean, nothing here they're stating is like convincing me. I'll just say that. Unintended consequences in type hierarchy. But I can see, like, if it was a different protocol, then I get it. But this is literally one property that has a very explicit use. And if there's no obvious, performance hit one might take by doing it, I just think maybe it was not the best example in that case, because they had just described the benefits of it and then in the same breath. So I think they're more than likely just sometimes you have a weak example, but the knowledge itself is valuable and has a way wider and girthier application and benefit than what the example provides. It seems like it's an example of that, because obviously these guys are very good teachers. For example, developers might start relying on description for other purposes other than debugging. Bastards. Such as application logic. Okay, I'm not gonna lie, I did think that was my first thought. It was my first thought when I saw, but is that such a bad thing, brother? Which can lead to fragile code that is hard to maintain and debug. Yeah, no, I mean, it definitely shouldn't. There shouldn't be any logic in the string itself. I agree with that. Okay, so +1 for that one. Code duplication and maintenance issues. If you later decide that a different textual representation is needed, you'll have to change the description implementation across all conforming types. Okay, but if it wasn't there in the first place, now you got to go add it to everywhere you need it. It's not a great argument to me. Which can lead to code duplication and increased maintenance effort. Yeah, I disagree with that, just because if there's a demand for it, there's work to be done irregardless of whether you're editing code or adding code. And they told us the benefit of using the description is so that you can control the specific way that it returns. The text. Otherwise, you just get that raw output. So I mean that, just just same opinion. I'm sure it applies and would be a better serve with just a different example. But I get why they used it with this, because it was already on topic, already in context. Okay, so alternative approaches, extension methods. Instead of inheriting from custom string convertible, you could use extensions to add conformance only when needed. Oh, that's cool. We haven't gotten here yet, but we did kind of see that earlier. But yeah, so I can jive with that. Jive turkey. This keeps the core protocol clean and focused. Extension. Tabular data source. So it's the protocol, and then extend it with custom string convertible. Another protocol. So protocol conforms to protocol. and then you give it the, oh. I don't know. I mean, to me, okay, if you do that, then oh no, it's still 5. Yeah, I mean, that would still not satisfy what they just said there. But I do like that. Maybe, I'm not sure. Implement separate helper functions or utility methods for generating descriptions. This way, the core protocol remains unaffected by the need to provide textual representations. Implement separate helper functions. Describe data source, and it adheres to tabular data source. Needs to return a string and then return yeah, I don't know. Composition over inheritance. Use composition to include custom string convertible functionality in specific contexts without affecting the entire protocol hierarchy. Okay, so yeah, again, one of those things we just need to observe. Just pragmatism, efficiency, those kinds of things would make in the consideration, because either way, I mean, like I said, I think I'd prefer this anyway. But I just wanted to clarify what they were saying. All right, so now I'm feeling like I just got a second win, so I think I'm gonna keep going, brother. Hell yeah, brother. All right, so then where were we before I went back? Make tabular. Okay, yeah. It is. No, we did that too. Yeah. Swift is an expressive language with lots of syntactically legal ways to accomplish most goals, including using protocols to codify type requirements. As you get more practice, you will start to get a sense for when certain strategies are more appropriate or more readable than others. Yeah, that's really the biggest thing. I get hung up on stuff like that because I really. And maybe that's why, man, I'm really starting to see just how much, on the one hand, it's frustrating to have many, many options. But on the other hand, like when I was working with Go, yeah, you can get to it quickly. There's only like 1 or 2 ways to do most things. But I'm sitting here bitching about certain things here. But I can also remember actually being in the midst of like writing I'm on a deadline. I need to write a program. I'm using Go, and I can remember that feeling of, I don't want to say dread, but there was a feeling of like, it's almost like if you can think of it this way, it's almost like one weekend. You mow your lawn on your John Deere tractor, the kind you ride around in, it's like a car, so easy, so you just do it. It just goes. It's still work. You still have to do some work, right? But it's a great tool for that job, so it's not cumbersome. Now, I felt like Go was like when your John Deere breaks down, you got to whip out the old crank thing, you gotta yank it, and you gotta prime it, fucking hope that it starts. Like, that's kind of, but it got the job done, and it wasn't terrible once you got rolling. There's just a lot of setup, and again, with the ceremony thing, you know what I mean? So, if I had to pick one, I think I would pick on this side of things, honestly. So I'm appreciative. Thanks, Go, for showing me what, some of the downsides can be to that. But yeah, we still love Go. No shade on Go. Honestly, if they had a better, I shouldn't say better, they actually have ways to, you can write iOS apps in Go. There's a cool little, it's not, I hate the word easy, but it's not, my main thing with those solutions is if the build system isn't, I don't know, it doesn't matter. We're not writing Go, so it doesn't fucking matter. But check out Whales. If you're a Go programmer or are interested in Go, just look it up. It's a library called Whales, and it's a way to write GUIs using embedded, like for example, you can embed your favorite framework in a Go binary and just have your backend and your front end all in one binary and just throw it on any system, and it's pretty cool, very cool. Especially if you already know, web dev. Okay, so mutating methods. And it's Whales, W-A-I-L-S, not the other one. Recall from chapter 14 and 15 that methods on value types, enums, and structs cannot modify self unless the method is marked as mutating. I do recall. So it was some of that action there. Cannot modify self unless the method is marked as mutating. For example, in the light bulb enum from chapter 14, the toggle method was mutating. Oh yeah, right there. Mutating func toggle switch self. Okay. Methods and protocols default to non-mutating. Methods and protocols. Okay, right. So these would be non-mutating by default. Suppose you wanted to find a protocol to do blah, blah, blah. Suppose you wanted to find a protocol to describe an object that is toggleable. Protocol toggleable. Func toggle. Declaring that light bulb conforms to toggleable. Do they want me to write that? I might as well go ahead and throw it down there. There we go. Protocol toggleable func toggle. Okay. Declaring that light bulb conforms to toggleable would result in a compiler error. The error message includes a note that explains the problem. Okay, so I guess I should have wrote that one too. Enum light bulb, case on. I love these case statements. It's just beautiful. And I don't have to put all these bullshit quotes around it and whatnot. Case off, pardon my French, and then mutating. What is that dot dot dot? What is that? Enum light bulb. I don't have that. We'll just break the rules a bit because I have a feeling they're going to tell me to delete it anyway. Oops. Okay. And then we should get. Oh. Default to non-mutating. Declaring that light bulb conforms to toggleable would result in a compiler error. Oh, I see. So light bulb conforms to toggleable. Error. Because we do not implement. Oh, because in the protocol by default it is non-mutating. But in the enum light bulb, we're saying it is mutating, so it's not conforming. Therefore, it get mutating, and now it conforms. Okay. The note points out that in Lightbulb, the toggle method is marked as mutating, but the toggleable protocol expects a non-mutating function. You can fix this problem by marking toggle as mutating in the protocol definition. With this change, value types implementing toggleable would now be required to make their toggle methods mutating. Here. But a class that conforms to toggleable protocol would not need to mark its toggle method as mutating, because methods on reference types are always allowed to change properties of self. Okay. Oh boy. Alright, so you've seen several different protocols now, and you may see a naming pattern emerging. Protocol names tend to follow one of two conventions set by the Swift standard library. Wait, you've seen several different protocols now, and you may see a naming pattern emerging. Protocol names tend to follow one of two conventions set by the Swift standard library. The name is a noun, such as tabular data source. Kids, for those of you that don't know, a noun is a person, place, or thing. At least back when I was in school, that's what it was. When the protocol describes the baseline behavior or meaning of a conforming type. So the name is a noun when the protocol describes the baseline behavior or meaning of a conforming type. The other pattern is the name is an adjective. So it describes. Adjectives are used to describe properties, characteristics of a noun with one of the suffixes able, ibble, or ing, such as equatable or custom string convertible. Ah, clever. When the protocol describes a subset of a conforming type's capabilities. When the protocol describes a subset of a conforming type's. Protocol describes a subset of the conforming type's capabilities. Okay. In the coming chapters, you will see and define many more protocols and see the different ways they lend flexibility to the types in your programs. I'll just go ahead and save that there too there, brother. Okay. Okay, now what? Bronze challenge, we're not going to do those. We will do them at the end to test ourselves. Electrum challenge. Dang, that's a new one. Above gold even, brother. Bronze, silver, electrum. It sounds expensive. Oh, there's gold. Also, electrum is below gold. Ah, man. Chapter 20, extensions. Yeah, we're gonna do it. Let's go ahead and do it. Imagine that you are developing an application that uses a particular type in the Swift standard library. That uses a particular type in the Swift. Okay. Say the double type. Quite frequently. So we use the double type quite frequently. That's the scenario. Okay. Based on how you are using it in your app, it would make your development easier if the double type supported some additional methods. Okay. Okay. Unfortunately, you do not have. Unfortunately, you do not have doubles implementation available. So you cannot add functionality directly to it yourself. What can you do? You do not have doubles. Oh, like we can't even see that like on GitHub? Is that what they're saying? Yeah, it doesn't matter. Swift provides a feature called extensions that is designed for just these cases. Okay. Extensions allow you to add functionality to an existing type. Oh, because it's probably, okay, it's probably, it's not that we can't see it, but it's like private or whatever, the access control, so we can't get in there. So Swift provides a feature called extensions that is designed for just these cases. Extensions allow you to add functionality to an existing type. Okay. So without actually amending the type, you can add to it So the baseline is always there, untouched. Yeah, that's pretty cool. I will admit, extensions kind of, just anecdotally, they just remind me of a bunch of languages that I did not enjoy, didn't like, specifically Java, Kotlin, JVM langs, but I digress. I mean, it makes sense. Okay, so extensions allow you to add functionality to an existing type. You can extend structs, enums, and classes. Cool. You can extend structs, enums, and classes. Ooh, I'll probably save this whole thing. You can use extensions on types to add computed properties, new initializers, protocol conformance, new methods, embedded types. So that's a nugget. Okay. In this chat, fucking bug. In this, God damn it. Oh. Fuck. Fuck. No, he got away. I didn't shut off my thing, did I? Oh no, we're good. Okay. All right, sorry about that. In this chapter, you will use extensions to add functionality to an existing type whose definition and implementation details are not available to you. You will also use extensions to add functionality to a custom type of your own creation. In both cases, you will add functionality to the type in a modular fashion, meaning that you will group similar functionality in a single extension. Okay? Extending an existing type. All right, so new playground time. Oh, what happened there? Here, brother. It's so weird. Like I'm in Xcode, but I'm looking at the web page. macOS is so weird. Playground. Call it extensions. Learning, create that. Okay, now you go left. All right. Consider the example above involving double. Imagine that you might regularly be computing the square of a number times itself. This is a common thing to do with numbers, but not quite common enough to be included as its own feature of the Swift standard library. Instead, if you need to square a number, you currently use the multiplication operator to do it yourself, 25x 25. In your playground, create an extension on the double type. All right. KDD, get rid of that line. I see the bug again. Go away. Extension. Double. Var squared. So a variable name squared of type double. Return. Run. Return self times self. Pretty trippy, brother. Let side length type double equal 12.5. Let area equal side length. So 12.5. Oh. Squared. Wait, so Swift provides square root, but not squared? Okay. Hey, brother, whatever. The extension keyword signifies that you are extending the double type. Inside the scope of the extension, you create new declarations such as computed properties or methods, and all your program's instances of the type now benefit from the additions. Oh, everywhere. That's pretty cool. Wow, yeah. Dang, let me highlight that. And damn, brother. Should have started out with... Okay, so... the benefit from that. In this case, your newly added squared property shows the result 156.25 in the results sidebar. Do it though. Let me see. Command Shift Enter. Okay. Appears correct. Extending your own type. You can also extend your own types. You might wonder why you would want to do that. Well, I can tell you why from past life. I mean, we would do this. Well, I didn't do it, but I would read the code, and it was generally understandable, but it was Fox Pro, so I had no desire to learn it. But yeah, we would do this for, you know, we had a distributed, well, not in the sense that it's used now, like distributed as in like on multiple servers, but it was just a local installation on the server. So it's just a separate instance, not talking to any web server. And if they wanted custom modifications relative to just their organization, you know, there's a base product, but we could still modify on top of that. And so we would use extensions for exactly that. Okay, so you might wonder why you would want to do that. If you created the type, why add an extension to it instead of editing the type itself? You will mostly use extensions on your own types for code organization. As you will see, extensions provide a convenient way to group related methods and behaviors, such as those required by a protocol. As you will see, extensions provide a convenient way to group related methods and behaviors, such as those required by a protocol. Oh, that's interesting. So you'd have protocols and then potentially like base types and then extensions on those types to satisfy whatever protocol that you define the type to conform to. Man, brother, man, speaking my language. That is, it's giving me like a programming boner, you know what I mean? Pause, but I'm just saying. So you will need to create a new type before you can extend it. Make a new struct to represent a car type and create an instance of it. Okay. Struct. Car. Oops, capital. Car. Open that body up, bust it wide open, let make. So we got constant, make, type string, let model, constant, another one, type string, let year, another constant. This is an integer and a mutable variable. Fuel level, makes sense, of the type double, so a decimal number. Who's buzzing my... Oh, 3 o'clock. Oh, time flies when you're having fun. Alright, so double will set. I don't think we've seen that yet. New keyword spotted. Will set. We saw it in a GPT example, but not in the book itself. So precondition, addition, new value is less than or equal to 1. Logical and, so we're saying and the new value is greater than or equal to 0. Okay, so anything between 0 and 1 is our precondition. Okay. Oh, whoops, not ready for that parentheses yet. So comma, new value must be between 0 and 1. Okay. 2, 3. And then let first car equal car. So an instance of a car, which is a value type, because it's a struct. And this one's make will be a Benz. Model will be... Do I have to put spaces? I mean, at least for my case, I don't really care that model. Oh, I don't have to. Yes. Patent. Motor wagon. Year is 1886. Fuel level is 0.5. Okay. Car string. So then on the fuel level, we'll have the ability to get this property also squared. Okay. Here you define and instantiate a new struct called car. The car type defines a number of stored properties that will be specific to a given instance. Yeah. In this case, first car. All the properties are constants with one exception, fuel level. Fuel level is a mutable stored property with a property observer. Oh, so is that what, that's what will set is, property observer? The will set observer will be called every time you're going to set a new value for fuel level. These values indicate how full an instance's fuel tank is in terms of percentage. Okay, let me just save the example as a reference point, although nothing too jarring. This makes sense to me. You use the precondition function. So that's just built in. So will set is an observer. And precondition is built in. Standard library. And it's ensuring new value being assigned to the fuel level property is between 0 and 1. This function takes a Boolean expression and a string message. So, yeah. And then our string. Okay. If the Boolean expression resolves to false, then the application will trap and log the provided message to the console. Okay. Oh, so it's, I guess if first argument is met, then do the thing, otherwise do the, like, return the second argument string, whatever's in there, to the console. It will trap and log. Okay. To a user, watching an app trap or crash is a bad time. So as a developer, you must weigh whether you can deal elegantly with bad input or if continuing execution would be meaningless. You will learn more about Swift's features for dealing with runtime errors in Chapter 23. Using extensions to add protocol conformance. Extensions are great for grouping related chunks of functionality, like conforming to a protocol. Extend the, I see it again. Extend the, it's almost like it only lands on shit that's like fragile or expensive. And it's just daring me and it's pissing me off. Okay, the extensions are great for grouping related chunks of functionality, like conforming to a protocol. Extend the car type to conform to custom string convertible. You know, for discouraging the the use of that thing, they sure do use it a lot in all these examples. Extension car. Okay, so we need to get an extension going, really. Extension car. Conforms to, so this is our way of telling the compiler that this extension should conform to, or this extension to car should conform to custom string convertible. Bust it wide open, then var description. So here's where we satisfy the requirement of having a property called description of type string. That is the requirement of custom string convertible protocol. And then we return, or we define our textual representation that we want. In this case, so year, make, model, fuel level. Fuel level. Okay. So now since first car is of type car and we extended car, to have the description, I should be able to, right? String describing. Got the print string describing oh, it's string. Yeah, baby. Get bent. All right, so okay, so that is what's cracking. So then, all right, I get that. Now extend the car type to conform to custom string convertible. Okay, we did that. Your new extension declares that car conforms to custom string convertible and implements the required property to do so. The syntax for conforming to a protocol is the same as when the conformance is declared in the definition of the type. The syntax for conforming to a protocol is the same as when, okay, yeah. They're just saying this is the same on the extension as it would be for if we had it here on the struct or an enum or a class. The syntax for conforming to a protocol is the same as when the conformance is declared in the definition of the type, and you implement the protocol's required property inside the extension's body. Right. Trying not to yawn. By declaring the protocol conformance is an extension, you keep the base definition of your type uncluttered. Right. So meaning, I suppose if you had a solid implementation of, in this case, your struct car, and you didn't necessarily want to fiddle with it, you could just stack functionality this way and keep the core the core. Yeah. And you implement the protocol's required property inside the extension body. By declaring the protocol conformance in an extension, you keep the base definition of your type uncluttered. When another developer, possibly you later, is learning about your type, the first thing they want to see is the essential list of properties and methods that show what your type is and what it can do. They do not care about auxiliary behavior, like whether it is custom string convertible. First thing they want to see is the essential list of properties and methods that show what your type is and what it can do. They don't care about auxiliary behavior. If you say so. By the way, extensions are an important exception to the access control rules you learned in chapter 16. Ah, come on, brother. Is nothing safe? Is nothing unfettered? An extension can access the private declarations. An extension can access the private declarations within a type as long as the extension and type are defined in the same file. Okay. I suppose that's a good thing. So you don't have to choose between access, level of access, and whether or not you can use extensions. So I guess that's a good thing. That's a compromise that would not, yeah, that wouldn't be a fun one to make. So if car had private properties, you could still use them in your extension, provided they're in the same file. Okay. Yeah, that's going to be probably want to board that one up. Right there, brother. Important exception for extensions regarding access control. All right. What was I? Adding an initializer. Okay. Adding an initializer with an extension. Recall that structs give you a free member-wise initializer if you do not provide your own. Yeah. So there's nothing in struct right now in terms of an initializer. So we could I guess that means like var bucket equal car, and I could do that because I need the arguments, but that technically is like me being able to do that is only possible because of the implicit initializer that's provided because I didn't specify one. But I would have to pass all the arguments, the make, the model, the year, and the fuel level. So if you want to write a new initializer for your struct but do not want to lose the free member-wise or empty initializer, you can add the initializer to your type with an extension. That's cool. That is cool. Yeah. Matter of fact, you might as well just, because I would like to remember that as well. Hi-yow. Alright. So, add an initializer to car in a new extension on the type. Okay. So another one. Extension car. Busted wide up. Initializer. Make. String. Model. String. Year. Integer. Yeah. Open the body. Self. Init. Make, model, year, fuel level. Yeah. Make. Don't bother Luke. Okay, model. Year. And fuel level is 1.0. Make, model, year. Oh, okay. So we're saying we could still use the member-wise, but in this case, we would provide an initializer, or we would only have to pass the make, the model, and the year. And if we don't provide fuel level, that's okay. We'll get a default value of 1. So now we have 2 ways to initialize. Okay. So if I do var bung equals car, and yeah, so there's our new initializer. So we only need these 3. So I can also make it this way. Okay, so oops, 1.0 and okay, there we go. The new extension on the car type adds an initializer that accepts arguments only for an instance's make, model, and year. This new initializer's arguments are passed into the free member-wise initializer on the car struct. So we're passing free, wait, the combination is preserved, no. Are passed into the free member-wise initializer on the car struct, along with the default value for fuel level. Yeah, so we pass that into the member-wise that's implicit in our car struct because we didn't define an initializer inside the body. So we give it these 3, and then the default value 1 fulfills the fuel level there. So everything gets satisfied. So combination of these 2, yeah. The member-wise initializer is preserved on car because the new initializer is defined and implemented on an extension. This pattern can be quite helpful. Agree. To see the initializer defined in the extension work, create an instance of car. Okay. Var current car equals car. Var current car equal car. Make Honda. Model Civic. Year 2008. Which means it'll run till 3008. Now first car dot fuel level. So we're accessing, wait a minute. Okay, so that's where the inheritance comes in. Not inheritance. Or no, I guess it is. But yeah, so first, this is first car because it's of type car. Via the dot notation, we can hop inside here and get access to the fuel level property, which for the first car is going to be the .5. Okay. First car fuel level, and then current car fuel level. Yeah, so it'll be 0.5 and 1. Command Shift Enter. Hot dog. Okay, so you create a new instance, current car, with the initializer defined in an extension on car. Take a look in the results sidebar. You should see that fuel level of first car is 0.5, the value passed into the compiler synthesize initializer in listing 20.2. However, the fuel level of current car is 1, and those are our results, so we got that right. However, the fuel level of current car is 1, the default value provided by the initializer you implemented in your extension. Yep. Nested types and extensions. Swift's extensions can also add nested types to an existing type. Say, for example, you want to add an enumeration to your car struct to classify the era an instance is from. Create a new extension on the car type to add a nested type. This would also be great for like prototyping because you don't have to, jack with certain things, but once it's, it gets through acceptance and all that, then maybe you can migrate it into the base type and then just iterate that way. So extension car enum era case veteran brass. Oh, cool. I didn't know you could do it on one line like that. Oh man, who doesn't love Swift? Okay, so modern case veteran brass vintage modern, and then var, so mutable variable era is of type era, which is an enum, so it can only be one of the cases defined. And then we do a conditional switch statement, so switch on the iterator year, which is an argument we pass, or which is a parameter that we pass to it, so switch year. And then case so I think it starts at 0, so that just means between 0 and 1890. Well, actually, I guess it depends on what we defined year as, which, okay, it's an int, so yeah. Oops. Capital G, go down into the line. Yeah, okay. Control E. 1896. Return. Dot to access the enumerations that we identified. So dot veteran, so that's how it knows where that's coming from. And then our other case between 1897 and 1919. Return the brass class. Case 1920. Oops. 1920. 1930. And that gets you a class or era vintage. And since switch statements must be exhaustive, we give it a default case, provided none of ours match to the input. In this case, the year. So if it's outside that range, then we say modern. So basically, if it's not in any of these ranges, then it's just going to make the assumption that it's in the modern era. This new extension on car adds a nested type called era. Era is an enumeration that has 4 cases: veteran, brass, vintage, and modern. Notice the simplified syntax for declaring the case of an enumeration. Man, brother, you should show me that earlier. All on one line, separated by commas. This syntax is especially convenient for simple enums that do not need raw values or associated values. Yeah, I like that a lot. I love that. boy, do I love it. Because then I can keep, because I don't necessarily like the idea of, yeah, whatever, it doesn't matter. I like that a lot. Okay, so the modern, especially convenient. Okay, the extension also adds a computed property on car called era, which determines the car's era based on its year. Exercise the extension's nested type by accessing the era property on the instance you created. Okay. First car dot era. And since first car was, wait. Oh yeah. 1886, and that's an old ass car. Shit would disintegrated by now. No, not really. But okay, so that should give us 1886 between 18 and 1896. All right, so we'll get a veteran. Should get veteran back. Hot dog, we got veteran back. Okay, so then exercise. You should see veteran log to the results sidebar. Extensions with methods. You can also use an extension to give an existing type a new method. You can also use an extension to give an existing type a new method. No wonder they use these everywhere. That's like a cheat code, brother. So for example, you may have noticed that car does not have any functionality to adjust the fuel level. Make an extension to add this functionality to car. If only upgrading our hardware was this easy. Extension car. Car, and can I, there we go. Okay, so now we have to explicitly define a mutating method, hence the mutating keyword. Otherwise, by default, it assumes immutable. So mutating func empty fuel, by being our external parameter name in this case, and amount being the internal parameter name, and double being its type. So a decimal number. I forget which of the two. I think a double. One is like 8 bits, and the float is 16, something like that. I need to look real quick. Double precision floating point. Top X. I guess it doesn't matter, but I do want to know. In Swift is a double, a float. Okay, yeah. Float's 32 and then double is 64-bit. Okay. Where'd I get 8 and 6? It doesn't matter. Oh, that's bit and byte. Okay, so where do we go? Expected. Oh, we're just now writing this. Okay. Type double, and the precondition here, amount. So we use the internal parameter name for the body of the function. We don't have any choice. Only external callers can use that. By. Well, actually, both have no choice. They can only use by. In the body, we can only use amount. Amount. Okay, so precondition. Oh, what am I doing? Amount is less than or equal to and the amount is greater than 0. So there's our precondition. Amount is greater than or equal to oops, 1. So anything greater than 0 up to the value of 1. And then amount to remove must be between 0 and 1. Okay. Close that bad boy up, and then fuel level, decrement operator, amount. All right, so in the operator itself, it assumes it's by 1, so it has to be by 1. Yeah. And then beneath that, so fuel level beneath that, mutating func fill fuel implementation body, next page. Hey, milestone cross page 500. Congrats to us. Fill fuel, and the logic is fuel level is equal to 1. Mutating func fill fuel. So you would call that method empty fuel by, and then some amount between 0 and 1, and then it'll take that amount you pass in, and provided it is between 0 and 1, it will decrease the fuel level by that amount. And then same here, mutating func fill fuel. But no. Oh, I guess that's just saying if you call it, you don't have to pass anything, and it's just going to add to the fuel level a value of 1. Or no, not even add, just set it to 1. Yeah. Yeah, okay. So, where are we then? We were at the top, fuel level 1.0, okay. Your new extension adds, I have to pee real quick. BRB. Hot dog, hot diggity dog. All right then, brother. Let's see where we at. 42, 73. Close that. Jared, can you close that? Yeah, thank you. Okay. Fuel. Oh wait, one more time. Need some water. Your new extension adds two methods to the car type. Empty fuel buy and fill fuel. Note that both methods are marked with the mutating keyword. Why? Remember that the car type is a struct. If a method wants to change the value of any of the struct's properties, then it must be declared with the mutating keyword. With the mutating keyword, yeah. The empty fuel buy method takes one argument, the amount of fuel to remove from the tank. Here. You use a precondition inside the empty fuel buy method to ensure that the amount removed from the tank is between 0 and 1. The implementation of fill fuel method simply sets the fuel level property on the car to be full or 1.0. Exercise these new methods on your existing type. Okay, so here we are lowering and filling the fuel tank. Current car, empty fuel by dot the type 0. I sure do. Okay, 0.3. Current car, fuel level. So we tell it to empty by 0.3, and then we call the fuel level just to see what it is. And then we now want to set it back to 1 and then view the fuel level again. Oops, fuel level. Command Shift Enter. All right, there we go. Current car dot empty fuel buy. So 08 Honda Civic fuel level is 0.7 because 1 minus 0.3 is 0.7, and then that would mean the current fuel level is 0.7, but then we set it back to 1 and the fuel level is 1. Pretty straightforward. After you use the empty by function, you should see in the sidebar that the fuel level is 0.7. After you fill the fuel level is 1. Extensions are an incredibly flexible tool for enhancing the organization of your code and adding useful behavior to existing types. Yep. One caveat on something you might see in the wild. Here we go. While extensions are primarily used to add new functionality, they can sometimes be used to replace existing functionality by implementing a method or computed property that already exist on a type. No. Okay, this is different from overriding a method in a subclass. Is it? And it is an advanced topic with limited utility and inherent risk. It is out of scope for this book. Or brother, why you bring it up at all? Well, I guess they said that. We'll see it out in the wild. Okay. Yeah, I can't. Let's just say we're far from that scenario, so maybe we should just be glad, brother. Generics. Man, we blazed through that. Hell yeah, brother. I think that might have been my favorite chapter of this whole book because, well, it just completes a lot of, or I should say it squelches a lot of the mental gymnastics I was doing in my head about some of this stuff. But that, actually, you know what it is? After learning about extensions, because we briefly saw it earlier, we didn't get to use them, but now that we know how they work, my brain is telling me that now I can fully trust what we learned earlier, which was that, again, going back to not using classes because of inheritance, or avoiding anything but final class to avoid inheritance. But now I can see how the complete picture comes together, where all the functionality that a class might provide could be, composed in a different way using enums, structs, protocols, and now extensions. So I'm really digging that. And I'm feeling pretty good, so I think I'm going to keep on going. Generics. This will be new for me because although I don't really even know truly what they are. So this will be completely new because Go, at least when I learned it, it didn't have generics. And by the time they added it, I was still using it, but I never, I'd already had my way of doing things, so I didn't need to grab for them. So this will be cool. And I want to do it, so we're going to do it. When we introduced optionals and collection types earlier in this book, we briefly showed you the long form syntax for each type, like optional, string, array, string, dictionary, string, set, string. Okay. Most of these types have a preferred shorthand syntax, like string, optional, or bracket string for an array of strings. And we did not really discuss the angle bracket syntax except to show you that it exists. True, I was wondering what that. And that damn T. What is that big T? We also told you that, for example, array string is not the same as array int, is not the same type as array int. Makes sense, yeah? And that is true, but the Swift standard library only defines one array. Okay. So what is the deal with the array string type and others like it? You're ready to find out. Hell yeah, brother, tell me. Optional and the collection types like array are what we call generic types. Optional and collection types like array are what we call generic types. Okay. Because they are designed, that's confused me a bit, but we won't dig there. Optional and the collection types like array are what we call generic types because they are designed to work with any type. Okay. With some limitations, and we will discuss. The angle brackets are the generic syntax. The angle brackets are the generic syntax. And they, along with the shorthand equivalent, some generic types have, allow you to specify the type that the generic type will work with. Okay. In this chapter, you will investigate how to define your own generic types. You will also learn how to use generics to write flexible functions and explore how generics are related to protocols. Do I still want to do it? I think I do. Generic data structures. You're going to create a generic. Well, okay, let me do this first. I knew it was coming, brother. I gotta exit. See, what I really wish is when I split the app, right, and I exit from one, that the other would just do it. What the heck? Yeah, good old. Alright, so close this one. And playground. Generics. I just thought of too, you can share playgrounds, so I could just publish the playgrounds too and annotate them because that might, it doesn't matter right now, but just thinking. So then these left, right, and the book, and switch. Give me a little more room, brother. All right. You're going to create a generic stack, which is a venerable data. Hold on, what does that mean? venerable. Not the venerable. Why would... Come on, Wikipedia, dude. Venerable. To display definitions, download the free dictionary. Oh, I was wondering why that useless ass box is empty. Alright, yeah, let's do that. But also not wait for that whole thing. Venerable definition. Accorded a great deal of respect, especially because of age, wisdom, or character. You're going to create a generic stack, which is a venerable data structure. In computer science, a stack is a last in, first out data structure. A stack is a last in, LIFO, last in, first out. Right, because you're pulling it off the top. So you put it on top. Can't get to this stuff till you take that one off. So it supports two basic operations. You can push an item onto the stack, which adds the item to the stack. And you can pop to remove the most recently pushed item off of the stack. Create a new macOS playground called generics and make a stack structure that only stores integers. Okay. Struct stack var items, so a variable, or I mean a mutable variable called items that will contain an array of integers, and we do the little empty tuple for initialization, saying that it'll be initialized and it'll be empty at first. Mutating func. So these are methods that we'll be able to call on the struct stack, or on the stack type, I should say. Mutating func push. And then for the function signature, we're saying underbar to allow for not having to give it, when we pass in arguments, we don't have to give the parameter name, which in this case is a new item. So the internal parameter name is new item and it's of type integer. And in the body, what's our logic here? Items append. Okay, so we're just adding whatever we pass in, append it to items, which is the array of integers. And then another one, func pop. No parameters, but we want to enforce the type on the return, so it'll be an optional integer, so it could be nil or it could be an integer. And then guard logical not operator, so guard against this condition, or for this against this condition. Items is empty. Wait, so that's saying oh, okay, is not empty. Yep. So long as it's not empty, else return nil. Oh, I see. So okay, that's guard because it breaks out if the condition isn't met. So if it is not empty, then it will return items dot remove last. So return the array, but remove the last element from the array. Yeah. Okay, so yeah. Remove the last item from the array, and then, all right. This struct has three. The item stored property is an array you are using. So and then here is an array you are using to hold on to the items currently in a stack. The push method pushes a new item onto the stack by appending it to the end of the item's array. Finally, the pop method pops the top item off of the stack by calling the last item and returns it. Note that pop returns an optional integer because the stack might be empty, in which case there is nothing to pop. Yep. Create a stack instance to see it in action. So var integer stack is equal to an instance of the type stack. And integer stack push 1, so we don't need to give it a parameter name because we have this little underbar, so it's not required. And then int stack push 2, so values 1 and 2 will be in our array, and 2 would be the last value. Wait, was that it? Push 2. Yep, that's it. Okay. And the print string describing int stack pop. String describing int stack. Oh, 3 times. Okay. I. How do I, is it P? P to paste. P. Nice. Okay. Command Shift Enter. All right, and we get the stack. There's 2 elements in there, R1 and R2. 0 to 1, 1 to 2. Struct stack items, 2 elements in the collection. I wonder why it's doing that, but or what that means, but I don't know. So the first print statement, it's an optional, so optional 2, optional 1, and nil because we popped off 2 and 1 from the stack. Interesting. Yeah, so for some reason, I mean, I know this is incorrect, but I'm just saying it out loud, is that I hadn't considered, I mean, print is just a function, so it makes sense that it can change things. I just didn't consider it in that way, but certainly that's what we're doing, calling that method. So, okay. Yeah, you create a new stack instance, push 2 values on, 1 and 2, then try to pop 3 values off. As expected, the console reports that pop. Oh, you want to see that too, so there we go. Optional 2, 1, and then nil, yeah. Your stack is, you create a new stack instance, push 2 values on, then try to pop 3 values off. As expected, The console reports that the pop calls return the integers you pushed in reverse order, and then pop returns nil when the stack no longer has any items. Optional 2, 1, and then nil. So we see that. That's correct. Your stack is useful for storing ints, but it is currently limited to that type. It would be better if stack were more general. Modify stack to be a generic data structure that can hold any type, not just int. Okay. Struct. Oh, not type. Okay. Struct stack element. And then var items is now element instead. And then all of these too, so element. And element. Element there, element, and okay. You define a placeholder type named element in the declaration of stack. So here, Swift syntax for declaring a generic uses angle brackets immediately following the name of the type to enclose the name of the placeholder type element. So that's what that is, a placeholder type. The placeholder type element can be used inside the stack structure anywhere a concrete type could be used. By defining the placeholder type element and then using it in place of int, you have made your stack generic. Okay. Now you can have a stack of any type at all, not just integers. Okay. There is now a compiler error where you instantiate a stack because you have not specified what concrete type should be substituted for the placeholder type element. Oh, okay. So generic in that sense, I see. So the implementation, the definition being generic, and then when you go to implement, you can give it any type. Dang, brother, that's pretty cool. Okay, I can see why they were. I can see why the Golangers that had experienced generics before wanted those. Okay. Dang, yeah. Okay, so damn, I would have wrote. Yeah, it would have been a lot less code, I'll tell you that. The placeholder type element can be used inside the stack structure anywhere a concrete type could be used. By defining the placeholder type element and then using it in place of int, you made your stack generic. Now you can have a stack of any type at all, not just integers. There is now a compiler error where you instantiate a stack because you've not specified what concrete type should be substituted for the placeholder type element. The process of the compiler substituting, damn hiccups, the process of the compiler substituting a concrete type for a placeholder is called specialization. You know it. The full details of specialization are outside the scope of this book. Dang. But the short summary is that it allows the compiler to make your app faster because the compiler is able to output code knowing the specific type in use. Your app faster because the compiler is able to output code knowing the specific type in use. Fix the error by specifying that int stack should be an instance of stack specialized for int. Okay. Fix the error stack would be an instance of stack. You will use the same angle bracket. Okay, yeah. So var int stack. Where'd you go, brother? There you are. is now left pointy, right pointy, stack int. I see. So that, okay, I like that. I like that it has the pointy brackets to separate itself clearly. Okay, this resolves the compiler error. You can now create a stack of any type. Create a stack of strings. All right, brother. Var string stack equals stack. Man, bro, that, okay, yeah. Why'd they leave those out of Go? That's odd. String stack push. This is a string. String stack push another string. So string stack push, this is a string. String stack push another string. Oh, strings. I was like, where's the error? String. All right, and then what? Print string describing our good old friend. Since it's of type string, we immediately get access to this method, string describing, because it's associated with the type string in the standard library, and then we can print the textual representation of string stack pop. Command Shift Enter, and we get optional another string stack. String, yeah. Oh, I get what it was. Okay, now I know why it was showing me that earlier. It's just showing, yeah, I keep forgetting. It's zero index, so it showed me at the 0 slot, there's the value 1. Yeah. Rookie mistake. Yeah, okay. String stack pop. Console prints optional another string. It is important to note that while int stack and string stack are both stack instances, they do not have the same type. Int stack is a stack integer. It would be a compile time error to pass anything other than int to int stack.push. Yeah. Likewise, string stack. It would be a compiler error passing. Okay. Likewise, string stack is a stack of strings, which is distinct from stack int. This is true even though you have defined only one stack type. Oh, one stack type. Yeah. Yeah, so it's like not even, I mean, it lets you do it, but it's not a real type. The compiler does something to it based off your implementation. Yeah. Yeah, okay. Stack int prints optional. Generic data structures are both common and extremely useful. Classes and enumerations can also be made generic using the same syntax. Hell yeah, brother. You used here for structures. In addition, types are not, actually, let me just go ahead. Actually, give me both of those passages there, guy. Just give me the whole thing. Give me the whole thing. Fix the error. No. That'll be good. In addition, types are not the only element of Swift that can be generic. Functions and methods can also be generic. Dang. Really? Getting hairy. Okay, there's that damn T, finally. Okay, so generic functions and methods. Think about the map method you learned about in chapter 13. Okay. On closures. Closures. Map applies a closure to each element in an array and returns an array of the results. Given what you just learned about generics, you can now implement a version of this function yourself. Add the following code to your playground. Some of it may seem unfamiliar. We will walk through it after you've entered it. Okay, so I'll refrain from running my yap then. So func my map left pointy T U for Texas University, obviously, and then arguments, anonymous external parameter name. Internal parameter name is items of an array of whatever T is. Same again, external parameter name, anonymous form, now an instance of T, no, so the second, the tax form, TX form, oh, takes a single element tuple of T and should return a U. I forget what they call that, but they're going to tell us, so I will go look in. And the return type for the function itself should be an array of whatever U is. Var results U. Okay, so we initialize an empty array of that type. Then a conditional for loop, so for item being our iterator, in items, which is the array of T that we pass in. So for each item we want result. For item in items, append it. To F, what the hell's F? Is it an F? Yeah, F item. Okay, and then return result. What the fuck is F? What is it? It's not. Okay, func my map. Func my map. TU. Open the arguments, and our items, T, TX form, T, return U, close that, return type, array of U, open it up, var result is equal to the array of U. We initialize it, and then for item in items, result append F. What the F item? I don't know what that. F item, close the loop, return result. Maybe it's one of those. Weird. The declaration of my map may look pretty ugly if you've not been exposed to generics in other languages. Instead of the concrete types you are familiar with, it just has T and U, and there are more symbol and punctuation characters than letters. But the only new thing is that it declares two placeholder types, T and U, instead of just one. Yeah. Figure 12.1 shows a breakdown of the function declaration.
When defining a generic type or
No, stop that. I thought I could blow it up, but okay, maybe. Don't make a goddamn sound. All right, so function. Oh, here's my map declaration. So function name, my map. Yep. In the angly brackets, two placeholder types, T and U. Parameter names. We get that. This is the input array. So each item has a type of T. Okay, makes sense. And then this is the closure definition. So closure that takes an argument of type T and returns a value of type U. And then the return value is an array. Each item has type U. When defining a generic type or function, you should give your placeholder types descriptive, meaningful names if you can, like T and U. Array uses element as its placeholder type name. Optional uses wrapped. It is common to use T, short for type, U, and so on if you require brevity, or if there are not more meaningful names to use. It is common to use T, short for type, U, and so on. They don't even say what U is. Texas University, that's got to be it. Now, okay, so those are just things, but they could literally be anything. So that's good to know. So the T that I always see, because you see that in TypeScript a lot. I guess it's just, I don't know that that's true in TypeScript, but in this case, it's just kind of like foo and bar always gets used, which is stupid. I hate examples like that. Just so, yeah, anyway. When defining a generic type or function, you should give your placeholder types. Oh, we read that. Type U, okay. My map can be used the same way map is used. Still don't know what F is. What? And it's there. It's still there. What the hell is that? Hopefully they explain it. My map can be used the same way map is used. Create an array of strings, then map it to an array of ints representing the strings links. Create an array of strings, and then map it to an array of ints representing the strings links. Losing it. Mapping an array. Func. My map. TU. Oh, no, it's just showing me where that, okay. So outside the body, we want let strings equal in the array of strings is 1, 2, and 3. Oh, I thought it would yell at me about the 1, 2, 3. Okay, and then let string links equal my map strings, string lengths, my map strings. Why don't I get... Oh, I need the... Okay, so then there's that trailing closure syntax. Subscripting with... I think that's what that is. So we're accessing the first element, the 0th element. And we're doing a character count. So that would be 3. 1, 0, 1, N2, E3, count, print, string, links. Oh, right. We still don't know what the hell F is. What the hell is F? And is it still... Oh, wait, I don't have... That's what I did. I left that whole chunk of... Wait, no, I didn't. For items in items, result.append f item. That's exactly what I have. Result.append f item. Return result. And then suddenly... we change it. So for item mapped items dot append. So yeah, if that doesn't fix it, then I don't know. Go to the forums. I don't know. We'll ask the Oracle. Okay, so my map can be used the same way. Create and array strings, map it. So we did that. Print string lengths. Can't see it yet, but the closure pass to my map must take a single argument that matches the type contained in the items array, but the type of its return value can be anything. The type of the return value can be anything. Where do you see the... Oh, here. Okay. The closure pass to my map must take a single argument that matches the type contained in the items array. So single argument here of strings. And it has to match the type. Wait, match the type of... Must take a single argument that matches the type contained in the items array. Okay. So it has to match the type in the items array. Which was... Well, in this case, it's... Where did it go? Not this one. Wait, do they mean items array or generically speaking, like what's here? Because then we don't know, but it would be strings if we're basing it off this array. Still not sure. The closure pass to my map must take a single argument that matches the type contained in the items array, but the type of its return value can be anything. In this call to my map, t is replaced by string and u is replaced by int. Oh, so this is t. This is u. Or, well, the whole thing is u. Describing map t u. Oh, right. This is the items thing they're talking about. Okay, so items. Yeah. And then it returns this generic type, and so I think think that's where the requirement comes from. Because the return type just has to be the same type that is replaced here. God damn that F. Darn the F. It's called to my map. The console confirms the result 335. Note that in real projects there is no need to declare your own mapping function. Just use the built-in map. Methods can also be generic, even inside types that are already themselves generic. Methods can also be generic, even inside types. Dang, generics inside other generics. The myMap function you wrote only works on arrays, but it also seems reasonable to want to map a stack. Create map method on stack. So, okay, so we're not getting an answer on what the hell F is. Oh, I'm curious if Big Nerd Ranch Guide Swift errata. There we go. Errata for seventh edition. In the entire book. Continue to improve. Oh, this is the iOS programming guide. Bangalore dating girl. What kind of programming site is this? The hell? Okay, look, brother. I just need to know. Big Nerd Ranch. Yeah, okay. This is a programming site, right? Okay. Make sure I'm not getting on a porn site on fucking stream. Services, boot camps, resources, books. Our books. Kotlin, Swift. Wait, what? I could have sworn this was Swift Programming, the Beginner Ranch Guide 7E. Blog, books, success, company. I wonder if some of these are. No, god damn it. Let's just see if the AI can probably get it sorted. We'll just give it the code. Not that one. Make it generic. Where the hell is the F? Funk my map. Yeah, funk my map. Oh, it's ahead of this. Push, describing. Make it generic. And then we got oh, there it is. example. Please help me debug. Below are the instructions and code provided. Yeah, I get that, but what could they have meant, brother? It's not defining code. The correct approach to use the transformation closure TX form that is passed as a parameter to my map function. Here's the corrected code. So what did you use form instead of F? Oh, that's it. I mean, that does make sense. Okay. So, oh, like F for form? Is that what they, maybe? All right, and so we get, no, where were we? Okay, so we mapped the array, we looked at that, print string links, and we got three, 5. All right, cool. Yeah, so 3 for 1, 3 for 2, 5 for 3. Okay. I guess I should be a good Samaritan and report that. The closure passed to my map. We'll just start here because I know I already read that, but now that it makes sense. The closure passed to my map must take a single argument that matches the type contained in the items array, but the type of its return value can be anything. The type of its return value can be anything. In this call to my map, T is replaced by string. So T is replaced by string Y. Because the first argument is just a placeholder. But here, when we actually call my map via type inference, we're passing strings, so it must be type string. And U is replaced by int, which again, through type inference, this closure is going to return an integer. So in the second slot, that is now type integer. The console confirms the result 3 through 5. Note that in real projects, there's no need to declare your own mapping function. Just use the built-in map. Methods can also be generic, even inside types that are already themselves generic. The myMap function you wrote only works on arrays, but it also seems reasonable to want to map a stack. Create a map method on stack. A map method on stack. So inside inside our generic stack. Okay. We want not a mutating func, just regular ol, so it won't be changing properties with it. Func map u. I just want to ask you real quick, what is, in case it gives me better insight, T made sense, but what is T and U supposed to? So T is the type of the elements in the input array, U is the type of elements in the resulting array. Okay, I mean, I get that. I just thought U might have stood for some, like T for type, U for something. No? Okay, fine. All right, so func map U. Func U, brother. And wildcard tx form. Tuple containing elements, element, and it should return a value. And the function will return a stack of the same type of the resultant value. I can see why they linked generics and protocols, because you're kind of doing the same thing, just describing the shape of it. And then you implement specifics when you have instances, var, so immutable variable mapped items. And that's equal to an array of the return value type. Oh, we don't know what that is yet. For item iterator in items, the array. For item in items. Maps items. Oh, so okay, there's items, yeah. In items. And we're just mapped items. Again with the F. Why are y'all doing this to me? You know it's not fucking F. Doesn't mean a goddamn thing. What's up with that? Item. Return stack. Items. Mapped items. So if U is meant, well, I don't know. I don't even want to say that if that's not correct. We'll see. So then this map method only declares one placeholder type, U, but it uses both element and U. I hate that these just random letters are used with no explanation. It really pisses me off, to be quite frank. The element type is available because map is inside the stack structure. The element type is available because map is inside the stack structure. Okay, that makes sense to me. We've seen that elsewhere. And it conforms to, not the protocol, but just conforms in the general sense to what we've learned about scope in general with this language. So the element type is available because map is inside the stack structure, which makes the placeholder type element available. The body of map is almost identical to my map, differing only in that it returns a new stack instead of an array. Try out your new method. A new stack instead of an array. What am I in right now? And then there. Okay. I forgot it just goes to the last one, so it kept taking me to the web page. But all right, so I need under int stack exit capital G, go to the bottom. And then under my pop functions, Wait, where are they at? Oh, they're there. Push 2. Var doubled stack equals int stack map trailing closure syntax to multiplied by the first element in the array. Two times the first element in the array. Oh, doubled stack. Okay. Okay, I got you. Okay, so then, and I got my print statements, and then I have some new ones down here. So print string describing doubled stack pop. 1, 2, yeah, print string describing double stack. Oh, literally the same thing. Okay. The new print calls show the doubled values in doubled stack. The new print calls show the doubled values in doubled stack. Oh, okay. Because 2 times 2 is 4. And 1 times 2 is 2. Okay. The output from all these print calls is not needed in the rest of this chapter. So if you want, you can comment them out to keep things tidy. How do you, is it control? No, command, nope. How do you do the multi-cursor thing? Control maybe, or option. That's not it. Oh, you can do that to get to the end? Man, I didn't know that. God, hot dog. Okay, so. Oh, right, that's how you do that. Okay, command slash. I think that's how you do it in SQL too. So, all right, and whatever, good enough. Okay, so get rid of those, get rid of those. Type constraints. Okay, so now I'm gonna go ahead and call it there, ladies and gentlemen. That was a good sesh, brother. Damn, we almost went 5 hours today. Yeah, so like I told you guys before, I made arrangements such that I will now be starting my new job July 1st because I wanted, the last thing I wanted, was to endanger me getting the job. But because of the situation, you know, things went so well, I felt like I had a good relationship with the boss man, so I negotiated that as part of because we were just, you know, we were going back and forth on the offer letter. But I really did not want to stop in the middle of this. Put too much work in, you know? Fuck all that. So anyway, we're gonna finish this. I'm telling you this so you can know what to expect. I'm gonna we are going to just start doing longer sessions like this because I want to get through this. And I may even skip the app planning part and just squeeze in, because we're already at 5:16. We're almost done with this book. And a lot of the later content in this book will have some, there'll be some redundancy. But my point is, I want to get through this. I want to get through SwiftUI. And I want to get through the next book, which is Big Nerd Ranch for iOS programming for the platform specific things, right? So these are going to be longer sessions. I'm just telling anybody this that's might want to whatever, you get what the fuck I'm saying. So that's the plan, all right? But they're going to be longer sessions, so if that impacts you in any way, you just have that information now. I guess that's all I'm really trying to say. So thank you for watching, and also, as always, make sure you check out my other stream, which is on tonight and every night, 9 p.m. Central Standard Time until, a few hours after. Halo Ranked, 100 Days of Halo Ranked Road to Onyx. We are on day 58 tonight, so make sure you check me out there too. Other than that, thank you for watching. We'll be back tomorrow at the same time, as always. And we're just gonna write this program. Thanks, guys. Take care of yourselves. Be nice to each other, and go have a nice, healthy salad or something. And don't forget to stretch. If you're getting older, oh brother, don't let it tighten up on you. You'll lose it. Don't use it, you lose it. Bye, guys. Take care.